I guess we can start now. So is it recording now?
Yes, it's recording.
Good afternoon, everyone.
This is just one course or the whole
Yeah, this is the entire thing we'll be covering
for
for like 2 months. So everything we have here, we are going to cover it for 2 months. So what we have on the board is the core synonyms, meaning those areas that we are going to look at. So for the first week, we have the number base, set theory, binary operation, modular arithmetic. So though we are going to start with number base in today's section. So also we have mapping and function for the week 2, polynomial, matrices, and determinants. But all these concepts, all these areas, they falls under number. Some falls under number theory, while some fall under abstract algebra, because those are the major branch of mathematics that we need to understand more for cryptography. So and also, so for the next slide, so talking about the introduction, so you guys need to know who is talking. So though I'm a software developer, so and I'm also a lover of mathematics, and my name is Korede. I'm Korede by name, though in school then I use SKY. The S is my surname, my middle name is Korede, while my Islamic name is for the Y, that is Yaya. So though I like doing our things, and I will be your instructor for this particular concept that we'll be looking at, which is cryptography. So for the objective, so at the end of the lesson, so learners are expected to understand this concept that is what listed. So meaning you understand what number base is all about, how to perform basic arithmetic operations in different bases. So all these ones, they are still mathematics. So we want to start from the basic before we move to the complex, like the main thing, which is the cryptography concept we want to look into. And also conversion from one base to the other. Then finally we look at the application of number base in cryptography. So like some of the application is what I have on the slide that we are going to look into. That is binary representation, bitwise operation, hexadecimal representation, base 64 encoding, and the rest, number theory, digital signature, hash functions. So now, what is number base? Let's start from that angle. What is number base? So number base actually what falls in a particular branch of mathematics, that is the number theorem. Number theorem has to do with the relationship and the properties of numbers. So to be more specific, the number will be emphasizing on is what integers, because we have variety of what numbers. We have natural numbers, we have real numbers, we have integers, we have rational, irrational, complex number, as the case may be. So though as we continue, you'll be introduced to what? To those concepts. You'll be familiar with, yes, when you see this number, this particular set of numbers, you know that yes, this one actually belongs to this set of numbers or group of numbers. So now, based on the slide, what we have on the slide, I said well, the study of number base falls under the branch of mathematics known as number theorem. So all what properties, like I said, number theory has to do with what? The relationship and the properties of what? Of numbers, right? Now, what are those word properties? Number one, talking about divisibility. So how does what numbers, how can we say what this one is divisible by what, by this one? We'll look into that. Also, this concept of key in our cryptography, because we know that the concept of cryptography, this is how it works. Maybe we have two persons in communication, talking about the sender and the receiver. So let's assume that we have James to be the sender now. You want to send a message to Pelumi, for instance. You understand now? And this what message will be done through a network. And this network does not what only contain what two persons. There are millions of people in that what connection, or it might not be up to millions. I'm just using that as what, as a case of as example. So now, what you want to send to Pelumi, if it is something that is confidential, so there must be a way to keep it secret. So now, what you want to send is a plain text, something that is readable. Whoever that have an access to it can see it clearly. So that means that plain text will be will be decoded using an algorithm. That algorithm is talking about the encryption algorithm, and that has to do with more mathematics. So now this encryption algorithm now, so alongside with a key, that key might be known between the sender and the receiver, because we have two types of cryptography, talking about symmetry and asymmetry key cryptography. So for symmetry, that is when both the sender and the receiver have same key. So they will use, normally, let's assume for instance that if you should go to a bank, for instance, now you have an access to a box where you can put your items for safety. And one thing is, let's assume that if this is a box for let's say person A, and the person B also has another box. So if both of them have same key, in that situation, person B can actually interfere with person A document. Isn't it? It will interact with that, right? But to avoid such thing, so there will be a padlock. There will be a padlock that it will just be that the person that owns that box, it will be the only person that will have an access to it through the key. So what I'm just saying then, because so that I won't just be moving around the bush. So when we get to that aspect, I will explain better when we start talking about the application and how number based, mostly binary operation, how it works. I said binary operation, pardon me for that. Binary numbers, how it come into action in that concept. So now, I said the study of number base falls under the branches of mathematics known as number theory. And by now, I think we know what number theory is all about. Meaning, it has to deal with the property and the relationship of numbers. But the number we are referring to here, they are the integer. So what are integers? We know that our counting numbers start from 0 and it go upward. 0, 1, 2, 3, upward like that. So that set of numbers is 0, 1, 2, 3 to infinity. We call that set of numbers natural numbers. And for integer, they are just a set of positive whole numbers, negative whole numbers, and 0. So that set is what we call the set of integer. I will make some clarity to that. Pardon me that what I'm still explaining is still abstract. So we are not seeing it written. So I'm going to write something down now. Pardon me for that. So what we are making emphasis on is what? Is integer, the set of integer. So the second thing on the list is that number base is the number of unique what? Digits, including 0, used to represent a positional numeral system. Though in our early world school, we come across numeration, numbers and numeration. So where they will be telling us about 100, tens and units, talking about the place value. So what we are doing here is more or less talking more about what? Numeral what? System. Or you say what? Numeration what? System. Number base could otherwise be referred to as what? Radius. Or we say what? Base, as the case may be. So, and we have different what? Base, in which what we can have numbers. So the common one are decimal what system, which is otherwise known as binary system. We have a binary system, we have the octal system, we have hexadecimal system. So decimal system, which is otherwise known as binary, that is in base 10. Binary is what? Base 2. The word bi means 2, right? So that means we have such number in base 2. And for octal, that is in base 8. So if you have hexadecimal, hexa stands for 6, decimal 10. So addition of 6 and 10, that means to be what? 16. So we have some other system, duodecimal, that is in base 12, and the rest. But the major one, the common one, that is the one I just will point out on the slide. Now, I'm sorry. So now, let us look at something. I want to give some illustration on what I've been saying. Now, though I talk about the set of what? Integer. That is set of integer. Set of integers. So this set of integers, we use the symbol to denote that particular set, capital Z, is what we use to denote the set of integers. And for my explanation, I said this set include 0, 1, 2, 3, dot. And to the left hand side of 0, those one will be what? Negative numbers. So we have -1, -2, -3, dot, like that. Meaning it is what? Infinite. It is open on both ends, both left hand side and right hand side. So now, this is the set of integers I talked about earlier. Now, what we want to look at, we are looking at what? Number base. So we can have, let me start with the common word base as we said we have on the board. Talking about binary word base. Like talking about binary numbers. So if I should pick this binary numbers. So we want to look at binary numbers. So the way it sounds, binary numbers, we've known that yes, these were numbers because we have system, right? So talking about the numeral word system. So and this numeral word system, we can have it in different base. So we can have a number in base 2, in base 3, in base 4, in base 5. So that is how it works. So now, for binary numbers, so these are numbers in base 2. They are numbers in base 2. So for a number in base 2, we only have 2 digits in such system, in such numeral. So what are they? 0 and 1. So if I'm looking at a number in base 2 for instance, base 2. So the set of numbers I'm going to have in this word base 2, they are going to be what? 0 and 1. Meaning it's going to be number starting from, that will range from 0 down to the what? The base number -1. So this is what I mean. If you want to know the number, like the range of numbers in this one particular one set of numbers or system we are looking at, it's going to be from 0 and it will range down to, we are looking at base 2, right? So it's going to be 2 minus 1. And 2 minus 1 is what? Is 1. So we only have 0 and 1. So pardon me for this dot 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 I have here, because we are only looking at whole number values. We are not looking at decimal values. Because if I say 0, dot dot dot, then 1. So that means the assumption is we have many numbers between the 0 and 1. But here we are only what? Focusing on the whole number values. When we mean something is whole, it is complete. We have a fraction. Fraction being is what? Part of something, meaning it is what? Incomplete. So that is the meaning. So now, let me generalize it. Let's say, for instance, I have a number in base, let's say base n, for instance. So if I have a number in base n, so what are those possible numbers I can have in this set? So if I want to list out the set of numbers or possible numbers that we can have in base n, so it's going to be from 0. So it will range from 0 down to what? M minus 1. So it's going to be 0, 1, 2, 3, dot dot dot, till we get to m negative 1. Please, am I communicating? Okay. So now, let's do something. So what we want to do now is, let's look at how to carry out some operation on number base. Operation like addition, subtraction, multiplication, and division. So let us look at that together. So if, for instance, I have this number 101 in base 2. So this number is what? Correct. Very correct. Because in base 2, the possible number we can have in base 2, they are just 2. That is 0 and 1. We can't have some other number except 0 and 1. Let's say we have a question like this: 1012 base 2. So maybe they are just trying to test our knowledge. Are we going to say this number is correct? It's not correct, in the sense that we are having 2 as part of the number, because we are working with number in base 2, and it's not possible for us to have 2 in base 2. We rather have number that is less than that base number, which is 2 in this case. So here now, so I'll remove this. So this one is a number in base 2. So if we have another number in base 2, how are we going to add such number together? That is what we want to look at now. So let's assume that I have 101 base 2 plus let's say 111 in base 2. So let's simplify this together. So it's going to be equal to, I have 101, I have 111. Both of them, they are in base 2. Now, it is very important for us to have it in mind that before we can add, or before we can subtract.
Sorry, please.
Okay, now. So before adding or subtracting, we must ensure that the number to be added, they are expressed in same base. That is where we can add. But there are some situations that will give us 2 numbers in different base. So in that case, addition cannot be done directly. You need to first take each of those numbers to same base. So here now, we are lucky. Both number that is involved here, we have it in same base. The first number is in base 2. The second one is also in what? In base 2. But there is one important thing we have to have in mind is that while working in a particular bit, in a particular base, we can't have that base number or higher number in that word system. For instance, I'm working in base 2. So what are those possible numbers I can have in base 2? They are what? 0 and 1. So I'm not expected to have 2 or what? Number what? Beyond what? 2. You get the concept, right? Now we want to add these two numbers together. Now let's do it together. It's still the same way we do add our number. But anything we are doing here, I will assume that we have zero knowledge. That is the assumption. So if you are lost in any way, please just let me know. So don't think that I know what I'm doing. I might not actually know what I'm doing. But your question can actually make me feel as if I know what I'm doing. Now, 1 plus 1, we want to add. 1 plus 1 will give us what? 2, right? But now we know that we can't have 2 in base what? In base 2. So that means we need to manipulate the result to 0 and 1. Because that is the only thing we can have here. So now, 1 plus 1, we have it to be 2, right? So these 2 now, I will need to play around this word 2. So these 2, what I need to do is what? I will divide it by the base number. What is the base number here? The base number is what? 2. So I will divide it by 2. So once I divide it by 2, I'm going to what? I will be after the remainder because it's the remainder that what we are going to use. So 2 divided 2 means how many 2 can we say in 2?
1.
So that is 1. Remainder what? 0. So now if you say 1 plus 1, the answer will be what? 0. The answer will be what? The remainder 0. But what of this 1 that we have here? We need to do something with that 1. So we are going to transfer this 1 to the next number. So the next number will be what? This. Because we are moving from left to right. Sorry, from right to left. Pardon me for that. Now, we now have 1 plus 0 plus 1 now. You know, the 1 that we have here is the one that we carried here, right? So now we have 1 plus 0 plus 1. So when we add that, what will it result to? So it's going to be what? 2, right? But in this case, we know that here it's going to be 0 that we are going to put down. So put down 0 and do what? We carry 1. Sorry? We carry 1. So this is the one we carry, right? Now, 1 plus 1 plus 1, what will it result to? 3. So are we going to write 3 here? No. So what are we going to write? If we want to know the what? The answer, we need to what? Divide that 3 by what?
2.
By the base number, which is 2 here. That is 3 divided by 2. So what will it result to? 1 remainder 1. So what am I going to write here? 1, right? Sorry. So I'm going to write 1. So what will happen then with this 1? So this other 1 that we have here now will be transferred to the next number, right? So you'll see that we didn't have anything here, but we'll just have to move the 1 down. So this is what we are going to have. 1, 1, 0, 0. Do you get the concept? So this is how to add. So let's add another number because we are still on what? Addition. So when we had 1, 0, 1 in base 2 with 1, 1, 1 in base 2, so it will result to what? 1, 1, 0, 0 in base 2. But the idea is for any base you are working on, for any what? Numeral system you are working on, it could be base 2, base 3, or whatever base, maybe base 10, or base 12, or base 11, as the case may be. So one thing is that we can only have number ranging from what is 0 down to what? The base number negative 1. So that means the base number will be what? Exclusive. It's not inclusive. Also, number what? Beyond the base number, they are what? Exclusive. Do we get it? Yeah. Now let us look at another question. We'll do the solving together. So let's say we have this. 11011 in base 2 plus 11011 in base 2. So this is what we have. So we can have the number of digits in any It could be that maybe we have 3 digits added to 2 digits, or there could be of what same digit number, as the case may be. But the most important thing, just understand the concept, how it works. The concept is, in base 2, the two numbers we are expected to have, they are what? 0 and 1, nothing more. In a situation that you are not having a number aside what 0 and 1, so you yourself will know that yes, you are doing what? Rubbish. You didn't need to be told. So I'm wrong. Okay, now we want to add this together. So it's going to be equal to, so let us arrange the numbers. So it will be 11011. So we have what? 1, 1. It is important you write this other one from the right hand side towards the left, so that you won't miss out the what? The place value. Shall you understand? Because numbers are supposed to be what? Under what? One another, and you decide to place it in another position. That is a problem. So we have 11011. So they are even of same what? Digit. So now we want to do what? We want to add. Now let's do it together. 1 plus 1,
0.
it will be 0. So we write 0, we carry 1. So 1 plus 1 plus 1, so that is 1, we carry 1. So now 1 plus 0 plus 0 is what? 1, right? This next one, what will it give? 0, then we carry 1. So this one is what? 1, 1. So that means we understood this concept like addition. So we understand that, right? Now we can now move to what? Subtraction. So let's look at what? How to carry out what? The subtraction. It's still what we've known. The normal way we work, we subtract. The idea is we are working in base 2. The two numbers we can only have is what? 0 and 1. So now let's look at question on what? Subtraction. For instance, let's say we have 1001. Okay, before I move to this, let me explain something. Using what we are familiar with. That is base 10. Number in base 10 that we are familiar with. Now, you know our counting numbers, they are all in base 10. So now, in base 10, for instance, now, you should know that the number should range from what? Can someone help us out? The number should range from 0 to 9, right? Thank you. So that is for what? Base 10. So let's assume that I have this 20, negative, let's say, negative 9, for instance. I want to solve this. So I know you know this. Just pardon me to what? To just make some clarity to this. Because back then in our what? In our elementary what class, so our teacher do give us what, some explanation that convinces us what more about this concept. So that is why I want to revisit this. So we have 20 negative what? 9, right? Now that means this 9 we have to subtract it from the 0, right? But 9 is more than 0. So in this case now, it's not possible. It's not what? Possible. Because the 0 is like nothing. A number beyond the 0 is what? Something. That is the word. The way we are saying it. So you want to remove something from nothing. So it's not making a sense. So now we just have to make what? That nothing up there to become something. So what we need to do is what? We will borrow from the neighborhood number. So the neighborhood number to 0 is what? 2. So we need to borrow from 2. But have it in mind that for every one we are borrowing is the same thing as what? The base number. So this 20, we have it in what base? Base 10. This other number is also in base 10. So to every one I'm borrowing is what? The same thing as the base number, which is the 10 here. So do we get the concept now? Now I want to borrow 1 from 2. So when the 1 gets to this what is 0, it won't be seen as 1. It will be received as what? 10. So is that 10 that will now be added to what? To 0. So 10 plus 0 is what? Is 10. So the new number here is now what? 10. So it's from this new number, that is when we remove this what? 9. You remember, from nothing, we what? We move to what? Something. So that we can what? Remove something from something. So now it will be 10 negative what? 9. So 10 negative 9 is what? Is 1. And here, it was 1 that what? We borrowed from this. So there will be a reduction in the value. It was 2 initially. So it will reduce to what? 1. So the remaining number here is 1. So we'll bring it down. So that is how we have 11. Now, the same thing that happened here also happened in all other base, whether base 2, base 3, base 4, or whatever base you are dealing with. So now let us look at base 2, because we want to look at how to subtract what? Base 2 number in base 2. So let's say we have this 1 0 0 1 minus 1 1 1. Both of them, they are in what? In base 2. So is equal to, now we need to arrange the number, so it will be 1 0 0 1, so minus 1 1 1. So now let's do the subtraction together. So what is 1 minus 1? 0, right? 0 negative 1. You remember, 0 should be seen as what? Nothing, right? And number beyond what? 0 is seen as what? Something. So you want to remove what? Something from nothing. You'll see that that concept is not what? Making a sense, right? It should be what? Something from something, right? So that means we need to borrow. So when you look at the number beside this one, the 0, we can't borrow from it. So we need to go to the next one where we can borrow. So that should be what? This one, right? So we'll be borrowing from this one. But you remember, for every one we are borrowing, it's the same thing as what? The base number. So now, if I borrow one from this one, which is the receiver, we receive it as what? It will be received as 2, right? So that 2 will be added to this 0. 2 plus 0 is what? That is 2, right? So the new number here is now what? 2. Please, do we get the concept? So from this 2, let me just write it here so that we won't be lost. The new number here is now what? 2. So from these 2 we have here now at the moment. But you might be saying that, but we are in base 2. We can't have 2 accepted. But we are having 2 here. But you know, that 2 that we have there, we still want to do something with it. So just hold on. Now, the new number in that position that is now 2. So we'll borrow 1 from that 2 to this one. This one will now become what? 1. This one will now become what? This one. It will become what? Which one? This one. This is 0. This one. It will become 2. Some people are lost. No, please, okay. So I'm referring to this 0. So now, we borrow from the new number that we have in this position. You know, the new number here is what? 2. Okay.
What you are referencing, you cannot see it.
Oh, I'm sorry. What if I should what? Do this. Okay, maybe I'll just make a dot. So for this one, the current number there is what? 2, right? Yes. So we will now what? Borrow from that what current number to this one that we have to be 0, right? So now if we borrow from this to this, so this one too will what? The new number here will be what? 2. It will be 2, right? Yes. We all accept. Yes. Because that 2 will be added to that 0, so we still remain as 2. So now, we have the new number here to be 2. So it's going to be 2 negative 1. 2 negative 1 is what? 1. Is 1. So here we have 1. So here now, what will be the remaining number here? 1. It is 1. 1 minus 1? 0. But if I should write the 0 here, let me just write it. And here, what is the remaining number here? 0. So we have 0, 0, 1, 0. But normally we can ignore what these 2 zeros. They have no what? Any significance. So it will be what? 1, 0. That will be our answer. So you can check it out on your calculator. When you press 0010, you'll see that the outcome will be what? 10. So that means this 0 is of no what? Use. For instance, if I should have, let's say, 003. 003 is what? The same thing as 3. But if I should have 0.003, this will still remain as 0.03. So just get the concept. Here there is no what point in between the zeros. But here there is what? Point. So that is that for that. So, let me solve one more question before giving you a question to attempt, like just to know maybe you are getting the concept. So now, so let's look at another question. So let's say we have this 1 0 1 1 0 1 1 minus 1 1 0 1 1. Like, let's say this is what we have. So the two numbers, we have the two numbers in base 2. We have the two numbers in what? In base 2. So now it's going to be equal to, you'll see that what we have been looking at didn't even involve points. So we could have binary numbers with points. So that one is known as well decimal. Like the way we have decimal. So decimal is what? Number in base 10. We could have 0, we could have it in point form, like in decimal form, like 0.235, like that. So now let's solve this together. The first step is what? We need to arrange the number. So let's do the arrangement. 1 0 1 1 0 1 1. So we have 1 1 0 1 1. Now the funniest thing is, what we'll be doing now, the base, they are positive base. But it is also possible for us to have a complex base, a complex number base, and also a negative word base. But what we are looking at for now, they are all what? Positive word base. Like a numeral system with a word, a positive value. That is what we are looking at. Now, looking at what I have here, now let's do it together.
Sorry,
Okay?
by negative base, you mean like base of negative 2?
Yes. So now, 1 minus 1 is what? 0. 1 minus 1 is what? 0 minus 1, 0 minus 0 is what?
0.
1 minus 1 is what?
0.
1 minus 1 is what?
0.
And this one will come down. Sorry. We have this. Then, okay. So we have 0, 1, right? 0, then 1. Like this, they will bring it down, then this one.
Remain 1 0. 1 0.
Sorry, 0, 0, 0, 1, 2, 3, 4, 5. Okay, 0, then 1. So you will see that this one is straightforward. There is no headache. In the sense that you didn't have nothing up there and you want to remove something from that nothing. So that is why it is very easy. There are some questions like that. But the one I will be giving you now, will what? What we will be having up there will be more of what? Nothing. So you want to remove something from nothing. So now let's see. I want to give you the question now before we move to multiplication, then the division. Before we now go to conversion, how to make conversion from base 2 to base 10. So whatever thing we are explaining now, is still the same way you are going to simplify all that base, all that numeral system in their respective word base. It's still the same concept. So now, so this is what you'll be doing for me. So We can start with this. Take your time. Okay, now for this question, we notice that the first number is smaller to the second number. So, and the idea is to subtract this second number from the first number. So here now, we should be expecting a negative result. So now, if we want to try it out, we have 1 0 0 0 1 1. We have 1 0 1 1 1 1. So we want to subtract this. 1 negative 1 0. 1 minus 0 is 1. 0 minus 1, is that possible? It's not. So we rather will borrow. But if we should borrow from this, if we borrow from this to this one become what? The new number here will be what? 2. So when we borrow from this to this, the new number will be what? 2 here, and this one will reduce to 1. From here to here, this one becomes 2, right? And this one too reduce to 1. So this position and this position, we have 1 1 here now to be the new number. So what is 2 negative 1? Is what? 1. Is 1. So here we have what? 1. What is 1 minus 1? 0. 0. Here we have 1. What is 1 minus 1? 0. Is 0. So now, here we have 0. But here, what do we have? We have 1. You can see that there is an issue. Issue in the sense that, issue in the sense that we have nothing up here and we have something down here. So, and we've known that yes, we can remove something from nothing. And there is no option of borrowing here. You understand? So here, we rather do it in the reverse way. Yes, in the reverse way. So for now, let us restructure the question by taking this one first and this one next. This one is too simple. Let me reframe it. I'm sorry for that mistake with the question I. No, it won't work like that. You have 0 minus 1. You can't just write 0 minus 1. Okay, 0. Sorry. We have 0 negative 1. So he said it should be what? Negative 1. So you might be right. So minus 1. Now I'm coming. We'll check it out.
Okay.
We'll check it out together. Now let me just digress a little bit to converting to base 10. So I will use the shorter approach. So now, let's say we want to convert each of these numbers to base 10, right? So now we'll just have to consider that yes, each of these number will use the weight of it, because based on each digit they have a place value. So the place value is like the weight. So since we are working in base 2, so it's going to be multiples of 2. So here now, this first number to the right hand side, talking about this one, can you see the one I'm touching? So it is going to have weight of 1. So if you want to know subsequent weight, you just be multiplying it by 2. So 2 multiply this 1, what do we get? What will it have? 2, right? 2 multiply this 4. 2 multiply this 8. 2 multiply this is 16. Then 2 multiply this 16 will give you 32. Talking about the weight, which is the place value in this case. So we are trying to look at the shortcut of playing around things. So now we want to convert to base 10. Pardon me for moving because we've not get to that concept. We just want to what? Check whether what we have here is correct or not. But it might be what? Correct. But to what? To be certain of what we are doing. So let us what? Check it out with what? Base 10. So also for this, we will do the same thing. So let's what? Arrange each of the what? The weight based on what? The position of the digits. So this one will be what? 1. No, we are working in base 2, right? So that means each of the weights should differ by what? By 2. Like differ in the sense that it should be times 2 heavier than the previous one. So if you are starting with 1, the next one should be what? 1 times 2. That is what? 2. That is 2. The next one is what? That will be 2 times 2. That is 4. The next one, 8. The next one, 16. Then the next one, 32. So what we need to do with this weight is to use it to multiply the respective what? Value based on their position. So this 32 will multiply 1. 16 will multiply 0. 8 will multiply 0 like that. So, and each of those values will be added together. So whatever thing we have will be the value in base 10. So let's do it together. For this, what are we going to have? 32 times 1 remain as what? 32, right? 16 times 0 is 0. Anything times 0 is 0. 8 times 0 is 0. 4 times 0 is 0. 2 times 1, 2. 1 times 1 is what? 1. So we'll add each of these together to get what this one will be equivalent to in base 10. So let's add 32 plus 0, 32. That same 32 plus this 0 is still 32. Plus this 0 is still what? 32. 32 plus 2, that is 34. Plus 1, that is what? 35. So if we convert this one to base 10, it's going to give us 35. So for this other one, let's do it together. 32 times 1, 32. 16 times 1, 16. 8 times 1, 4 times 1, 2 times 0, 1 times 1. So let's add together. 32 plus 16, 48. 48 plus 8, 56. 56 plus 4, 60. Plus 0, 60. Plus 1, 61. So that means we have 35 minus what? 61. So if I should have this, if I should have 35 minus 61, so what will it result to? Minus what? 26. So looking at this 35 is having plus at the front here. Front here is having plus. So the idea is if you have plus, it means you have. Let us explain in terms of money. Plus means you have. Minus means you are owing. Yeah. So now, you have 35 naira. Minus 61 means I'm owing someone 61 naira. You know, I'm owing more than what I have. So if I pay what I'm having, I'm still owing how much? 26. So this minus here is showing that you are owing 26 naira. So we now have to take this 26 back to base 2. So we are just trying to check maybe this answer is correct or wrong. So now,
Sorry for
okay.
Please, I kind of got lost at the point where we were rounding to 16, 8, 4, and my height is
You see all these 32, 16, 8. So those values that is up there, they are just the place value. So based on the position of each digit, there has a value. So and this value, it depends on what, like it will just be the weight of the base number. You know, the base number is 2, right? So that means we'll first start when the weight is 1. So I will keep multiplying by 2 to get subsequent what? Weight number. So I have 1 here. To get the next one, I'll just have to multiply the 1 by 2 since I'm working in base 2. So I have 2. So these two result 2, I'll multiply again by 2, 4. 4 times 2, 8, like that. That is how you get what? Each place value or weight of each of those what? Respective or digits. So I believe that one is settled right. I can continue. Now this 26, we have it in base 10. So we want to take it back to base 2. Taking it back to base 2, we'll just have to be dividing this 26 continuously by 2. And as we are dividing, we'll be recording down the remainder. So now, I have 26 here. So I want to be dividing it repeatedly by 2. 2 in 2, 1. 2 in 6, 3. So what do we have as the remainder? 0. The 0 is what? Is the remainder. So we go again. 2 in 6, in 13, 6. Remainder what? 1, right? So we go again. 2 in 6, 3. Remainder 0. 2 in 3, 1. Remainder 1. 2 in 1, 0. Remainder 1. So our answer is what? 1, 1. We'll take the reading like the answer. We'll read it from the down value to the up value. That is 1, 1, 0, 1, 0. So it's going to be minus 1, 1, 0, 1, 0. So you can see what I'm saying now. That we doing like this will be wrong. You can see the answer does not correlate. Do you get the logic? So that is why I say what? We need to what? To make that conversion to base 10. So after converting to base 10, you do the subtraction in base 10. So you know that it's only this number we want to convert. We have no business with the negative. The negative will still remain in that same position. So we just what? Get the equivalent of 26 in base 10 in base 2. And that is what we just did here. Do we get that?
Yes, sir. So, I think I have a question.
Okay.
So how do we do our 35 to minus 61?
Okay.
We do it like we just, I know we know the answer, but if we want to like simplify it.
Okay, we'll look at that later. It's part of what we'll be looking at. But let me just what? Answer your question. So the idea is we are converting from base 2 to base 10. It's possible for us to make conversion from one base to another. Now we are looking at how to move from base 2 to base 10. Base 10 is known as decimal system. A number in base 10 is known as what? Decimal number. But the system itself is what? Decimal system. You get? So we want to move from base 2, which is binary, to what? Decimal. That's what we are doing. So, and the idea is what? I have this number. The short way of doing it is we what? Recognizing what? The weight of each of what? Each digit number. So for each of this number here, for each of the number here, they have their own weight. The weight is the place value. Value that is attached to what? To each number based on what? Their position. So now this first value, the weight will be 1. So that is the one that is written up here. So if you want to know subsequent weight, you just have to be multiplying by 2. Because the base number is what? Is 2. Do you get me? So if I multiply 1 by 2, which is the base number of this number. So when you multiply 1 by 2, what does it give? 2. So you multiply this one 2 by 2 to get the next one. 2 again to get the next one. So that is how it works. So if you now want to get your answer, the weight times the value for that position, that is what you will do. So you will do it for each of the values, then you then add all the results together to get your answer in base 10. Do you get it now?
No, that's not my question.
Okay.
After we got it in base 10,
Yes.
how did we do the subtraction?
Oh, okay. So how do we know that 35 minus 61 is minus 26? That is your question.
That's my question.
Thank you. Now, it is very important. That is why I'm trying to what? To take it to money aspect. You understand? Because we deal with money every day. We can easily correlate that together. So now, we've already seen that this answer here is wrong. This one is wrong. So let me erase this. So now, how did I know that 35 minus 61 is minus 26? Now, if you have plus, always have it in mind that it means you have. It means you have. And minus means what? You are owing. Owing. Meaning you are owing. Now, for instance, let's say I have plus 2 minus 5. So pardon me for going back, because we are trying to come from what? From the basic to what? To complex. So plus 2. Number one thing is plus means I have. Meaning what do you have? Money. I have how much? 2 naira. This minus is owned by what? By this 5. Minus 5. It means I'm owing 5 naira. Imagine you have 2 naira, but you are owing what? Belumi, 5 naira. Now you can pay the money with you, with the 2 naira, but will you still be owing Belumi or not? So the indicator to let us know that yeah, you are still owing is that negative. So that is why the answer will become minus 3.
So what I'm saying is, if we're going to be using that up-down approach,
Okay?
this minus this equals to...
Exactly. So in this case, that arranging of numbers in columns will fail in this scenario. Fail in this scenario in the sense that we won't get what we are expected to have. So there are some certain things in mathematics that the more you keep getting to a particular stage, they will be telling you that what you have been taught initially fails when certain condition would occur. So you'll see that there is invention of a complex number, because mathematicians they encounter with a particular problem of solving a certain equation. That is that give birth to complex number and some other concept. We'll also look at Feynman's little theorem. How important it is to to encryption, like in cryptography. You know, it is very difficult to factorize or to guess very big prime numbers when you multiply them together. And that is what they use for these keys. So it is very very hard to predict or to factorize. So if such number is being used, so we'll look at those manipulations. You know, you when we started, I was talking about number theorem. So saying that it has to do with properties and relationship of numbers. So those relationship and property could be GCD, meaning greater common divisor. That greater common divisor is referring to to our ACF that we are familiar with. We'll look at the computation behind that. And while talking about, when we start the introduction of cryptography as a topic, we'll look at divisibility more as a concept. Prime number also, we'll look at it more in more details. So back to your question. So what I'm just saying is that in a situation where we have small number minus a big number, the arrangement in column method fails in that scenario. So you rather treat it in another perspective. Other perspective in the sense that you might assume that the big number up, the small number down. So subtract the small number from the big number, then you know that your answer should be negative. So that is how we should that is how we thought to have approach that question. So you see that it will result to the same answer. So I think we can do it like that to compare it with what we have there, which is minus 1, 1, 0, 1, 0. Please, do we get that?
That's what I'm getting.
Do you get that?
Yeah, so basically now there's a rule for binary general, especially those lower than the standard. Once you discover that the number you're trying to subtract is lower, like you have a lower number trying to subtract a higher number,
Okay.
convert, and just like it's a base rule,
Exactly.
like convert, instead of saying you want to use your head to do it, just convert to base 10, then only once you get your exact number back.
Yes, it's one of the way, because there are different ways we can approach a single question. So another approach that will be what? More faster. Another approach that will be more faster in this case is we placing the big number up, subtract the small number from it. But in the real question given to us, is the what? The big number that is subtracted from the small, right? So in that situation, our answer should be negative. That means anything that we have afterwards, placing the big number up, then the small number down, afterwards subtracting, so the answer should be what? Negative. Should be minus that value. Do we get that? Now let us all try that together. So I want to erase this. We try to digress to what we are here to to cover. So pardon me for that.
So,
Just to make clarity, that is why.
so what I'm trying to get at is, the instance where we took it back to base 10,
Okay?
we had to do that inverse.
Okay.
Because if we were explaining it to someone that does not know 2 minus 5 is equal to minus 3,
Exactly.
we have to turn it, right? And now add the minus
Okay.
afterwards.
Yes.
So instead of going to step 1, convert, then go to step 2, inverse, then go back and convert, why don't you just inverse?
Exactly. That is what I want us to do together now.
Please, sorry. We need to.
So now I want to look at. It's not recording. Please, your charger. I need to plug this. Is it recording now? Okay. So let's continue. So this is what we have. See, we notice that the up number is smaller to the what? To the down number. And it's the down number that we are to subtract from the up number. So this is what we are going to do. Anytime we have small number minus big number. So our answer should be minus big number minus small number. Do we get it?
Yeah.
So it's just like we reshuffle it, but in such a way that when we reshuffle it, there will be what? Minus outside. Do you get the concept?
Yes.
So now let us treat what we have inside the bracket. We is what? Big number minus small number. So the big number here is what? 1, 1, 1, 1, 0, 1 minus 1, 0, 0, 0, 1, 1. So it's equal to 1, 1, 1, 1, 0, 1, 1, 1, 0, 0, 0, 1. So we want to subtract. So what is 1 minus 1?
0.
So 0 minus 1 is not possible, right? So here we need to borrow, right?
Yes.
So when we borrow to this one become what? 2. So what is 2 negative 1? So what do we have here now?
0.
So 0 minus 0 is what? Yeah, we still have 1, right? So 1 minus 0 is what? 1 minus 0 is what? And 1 minus 1 is what? 0, right? But you know that what? This one is still the same thing as 1, 1, 0, 1, 0, right? So now, is this the same thing as what we have initially? It's the same thing, right? When we convert to base 10. So that is the ideology in tackling what this. So that means our final answer, our final answer to this, based on this one that we are using, saying, say small number minus what? Big number, that become this. So that means 1,0,0,0,1,1 minus 1,1,1,1,0,1 will be equal to this negative, will be this negative of what we have in bracket. The entire bracket result to this 1,1,0,1,0 in base 2. So we've seen two ways of doing it, but this is the fastest of the two approach. So someone wants to ask a question. So now, please, let me give you another question to attempt. Sorry, I won't make that mistake again. Okay, you guys do this. Also, you can solve this once you are done on addition. So those are the two questions. Right. Okay, now. So I want to erase this so you remind me of this second question because of space. So what we have here is equal to, we have 1 0 1 1 0 0 1, right? Minus 1 0 1 1 0 1, right? So let's do it together. 1 negative 1 is what? 0 negative 0. 0 negative 1 is not possible, right? So borrow from this to this. So this one will become what? 2, right? Let me just indicate it. So that means we have 2 negative 1. 2 negative 1 is what? 1. So yeah, what do we have left here? 0, right? So 0 negative 1 is what?
0 negative 1, not
Borrow.
Is 0 negative 1. So we borrow from this to this. So this one become 2 now, right? Because what we have here initially is what? Is 0, right? So the new number there is now what? 2. 2 negative 1 is what? 1. So what do we have here now? 0 negative 0. And here we have 0 negative 1. So we borrow from this to this. This one becomes 2, right? 2 negative 1 is what? 1. You know, we have 0 here. So I can decide to write this 0 or I can what? Ignore it, right? So we know that we'll see later ignore it, so there's no need of writing it. So our answer is what? 1 0 1 1 0 0 base 2. So is that what every one of us have?
Yes.
Wow. Thank you. That means you are giving me hope that I'm not just talking.
Yeah.
I appreciate that.
See if you get something.
So one thing is mathematics does require you practicing. So when you want practice with more questions to be part of it. So the second question, can you help me with that?
1 0
1 0.
1 1
How many 1?
1 0 1.
Plus what?
1 1 1.
How many 1?
3. And okay, we're starting from okay.
0 1.
0 1.
Like this. Is that all?
1 1 1 0
1
1.
1 1 0 1. Like this, right? So it's equal to. So now it's going to be. So we need to arrange, right? So we have 1 0 1 1 1 0 1 plus we have 1 0 1 1 1, right? So now let's add together. 1 plus 1 is 0, right? So that would be what? 0. We then carry what? 1, right? So this is the 1 that we carry. So 1 plus 0 plus 0, 1, right? 1 plus 1, that would be 0, then we carry 1. So 1 plus 1 plus 1 will be what? 1, carry 1, right? 1 plus 1 plus 1 is what? 1, carry what? 1, right? 1 plus 0, and we bring this one down. So the answer is what? 1 1 1 1 0 1 0. So now, thanks for that. I really appreciate. So that is how to add and how to subtract number base. So though we make emphasis on binary what? Numbers. So the same way we carry out the addition and the subtraction here. That is how the addition and the subtraction is going to be done on all other base. Maybe base 3, base 4, octal base, decimal, duodecimal, etc. So now, I guess we are.
Offline.
I guess we need to stop. When do we start? When do we start? Or do you still guys want to continue?
Let's continue.
Okay, now let us look at multiplication of binary numbers. How to multiply binary numbers together. So now, have it in mind that there is no how multiplication will be considered that the final product will lead us to what? Addition. So that means like there is no how we will multiply without what? Resulting back to addition. So that means for us to get the final result for multiplication, we will need to add. So that means multiplying will still later lead us to addition. And also division will lead us to subtraction. So now, let's use what question? Let's consider, let's say we have 1 1 0 1 in base 2 times 1 1 1 in base 2. So we want to multiply these two numbers in base 2. Since both numbers they are in base 2, we can carry out the what? The multiplication immediately. So now we need to arrange, that is 1 0 1 times 1 1. So now let's do the multiplication together. This first number here will multiply what we are having up here. So 1 times 1, 1. 1 times 0, 0. 1 times 1 is 1. So it's now the turn of this to multiply what we have up here. So 1 times 1, 1. 1 times 0, 0. 1 times 1, 1. So now we'll add. That is why I said what the final what? Product will be done with what? Addition. So now let's add. This one will move down. 0 plus 1. 0 plus 1 and 1 then move down. Very simple. Is it not simple? Simple. So this is our final answer. When we multiply 1 0 1 by 1 1, it's going to result to 1 1 1 1. So can I move to another question? So let's say we have this 1 1 1 times 1 0 1. For instance, each number we have it in base 2. So it's going to be equal to 1 1 1 times 1 0 1. So let's multiply. At first, we'll start the multiplication with this. Then we'll move to this. Then we'll move to this. So this one, we first multiply everything up here. Then this one will multiply everything up here. Then this one will also multiply everything up here. Do you get it now? So now let's multiply together. 1 times 1 is what? 1, right? 1 times 1 is what? 1. 1 times 1 is what? 1. So it's now the turn of this 0 to multiply what we have up here. 0 times 1 is what? 0 times 1. 0 times 1 is what? 0. 0 times 1 is what? Is 0. Then 0 times 1 is what? Is 0. Then we'll multiply with this also. 1 times 1 is what?
1.
So 1 times 1 times 1. So this is what we have. So we then add. So now, this we have this, right? 1. 1 plus this. 1 plus 0. 1 plus 0 plus 1.
0.
So it will be 0. 0 carry 1. 1 plus this is what? So that is 0 carry 1. And this plus this is what? 0 carry 1. So this will be the result when 101 multiplied 111. So we'll stop here. Do you have a question? Any question from anyone? So this is what we. Okay. Now, this one is just like a review of our last class. Though this is not what we actually will discuss in depth. But we are coming from this angle because it is a branch. What we actually consider falls under this branch of mathematics. We is what? Number based. But the branch we are looking at is what? Number theory. There are still some other concepts we look under this. Talking about divisibility, Fermat, Little theorem. It has more application when it comes to equation. So, for the number theory, I said what? It is a branch of what? Mathematics that deals with properties, likewise the relationship of integers. Because if we say numbers, we have varieties of numbers. Numbers can be classified as natural numbers, irrational numbers, rational, complex, etc. So we have real numbers as a set of numbers. But our main focus here is what? Integers. And I try to what? To demonstrate, or I give an example of an integer. Integer, we use this symbol Z to denote that set. So that set actually consists of whole number, positive whole number, 0 and negative whole number. Those are the constituents of that word set. So now, back to this. So they are talking about the properties and the relationship. So we are talking about the divisibility. So what I actually mean by divisibility is that, for instance, if you have a number now, so there are some certain number that can divide in another number without a remainder. Our assumption is the remainder will be what? 0. So for instance now, if I should have 4, for instance now, coming. Let's say for instance I have 12 for instance. 12 is a number. So looking at this 12, there are some certain number that can divide what? 12. Do you understand? So this 12 is divisible by 1, is divisible by 2, 3, 4, likewise or 12 itself. 6. We have 6 also. Time for that. So all these numbers, they are numbers that can divide what? 12. Do you understand? So the divisibility is just talking about how are we going to know that this number can divide this, or this number cannot divide this number. So there are some more rules behind that. Like for instance now, if a number is given to me and I want to know whether 2 can divide such number, and if a number ends with an even number, so that means 2 can divide the number. So what did I mean by what? A number ending with what? Even number. So let us come from this angle. What is what? Even number. Because number theory is talking about everything about numbers. And for this cryptography of a thing that we want to look at, we have one number that is very crucial, very important for us to understand how the manipulation is being done. That is what? Prime numbers. Because the encryption the secret key, we actually use that private word, sorry, we use of prime numbers to generate those values. We will use a very big prime numbers, two big prime numbers. When we multiply them together, it will be very difficult for an attacker or anybody to think of those two numbers in terms of factorizing them. So now, I said all these numbers, they can divide this. But now I want to try to explain some divisibility rules. Like for instance, if a number is given to me, how will I know that that number is divisible by 2? So once the number ends with any of this, is 0, 2, 4, 6, 8. If we have any of this to be the end number, so automatically that number is divisible by 2. If any of this is the number that ends a particular number, so just conclude that this number is divisible by 2. So if I have a number like this, 1, 0, 4, 8, and I was asked, is this number divisible by 2? The answer should be what? Yes, because it's one of these that end the number. So let me just move to 3 also. So how will I know that a particular number is divisible by By 3. For instance, let's say I have this 12, for instance. If I want to know whether this number is divisible by 3, once the sum of the digits result to a multiples of 3, that tells us that that number is divisible by 3. So I might be using some language that it might not be conversant to it. But pardon me, I will try to explain in a layman way. So what I mean is that for this number that we are looking at is 12, right? So those two numbers that we have in there is 1 and 2. So I want to confirm whether 3 can divide this number. So those numbers that is found here, we are going to add them together. If it results to multiples of 3, what I mean by multiple is number that we get as a result of we adding 3 to itself continuously. Like if I start with 3, so that means 3 is multiples of 3. So if I add another 3 to 3, what will it give?
6.
Another 3 to 6, 9, comma, dot, dot, dot. So this one, you are forming a sequence like this. So this sequence is actually multiples of 3, because there are numbers that 3 can divide, or we can say it's just the number that we get as a result of it accumulating 3 to itself. Do we get that? That is multiples. But I want to explain how to know that this number is divisible by 3, right? So those two numbers that is present here is 1 and 2. So the number that is present in this given number, we are going to add it together. Once the result is a multiple of 3, that makes that number divisible by 3. So I will need to add these two numbers together. 1 plus 2. Those are the two numbers present here. So if I should add 1 plus 2, what will it result to? Give us 3. So is 3 a multiple of 3? Yes, that means this number is divisible by By 3. Meaning 3 can divide this number. Please, do we get that? Now, if I have, for instance, I have 5, 1, 2. Now, I want to ask a question now. Let's say we were asked that, is this number divisible by By 3? 5, 1, 2. Our answer be yes or no? No, in what sense? Can you tell me a reason why it is no? Exactly. But now, if you look at this, 108, is 108 divisible by 3? Yeah, it is, because the summation of the entire digit result to 9. And 9 is a multiple of 3. So that is that for that. So we also have some other rules for all other numbers. So I just like to explain that of 2 and 3. So that explains divisibility as a property or relationship we are talking about in number theorem. We also have prime numbers. Now, what are prime numbers? What are prime numbers? So what? Okay, number divisible by 1 and itself, meaning you only have 2 divisor. So, and the 2 divisor is what? The number itself and 1. So, we can give what examples of such numbers. So example of such numbers, example of prime numbers now, we have them to be, so what will it be? It will be what? 2, 3, 5, 7, 11, 13, 17, 19, comma, dot, dot, dot. Just to mention few. By the way, 9 is not there. Now, looking at all these, they are prime numbers. Why? Why are they what prime numbers? From the definition, prime number must always have what 2 numbers. To be is what divisor, meaning they are divided by what 2 numbers. That is what the number itself and 1. So all other number cannot what divide what such number except 2 numbers. That is what the number and 1. Now, why is it that what 1 is not a prime number?
Because it does not have 2 divisors.
Exactly, because it only has what. Okay, now back to where we stop. So here now we are trying to look at prime numbers, and these are examples of prime numbers. We all know that prime numbers, they are numbers with 2 factors, itself and 1, meaning such number is only divisible by 2 numbers. That is that number and 1. So an example includes 2, 3, 5, 7, and so on and so forth. So all these numbers, we understand the fact that no other number can divide them. It's only what the number and 1. So we are going to leave that. Also, we have to have it in mind that every single number can be expressed as product of what? Prime numbers. So there is what we call prime factorization. So prime factorization will teach us how to what? To express any number as product of its prime. As product of its prime. Okay, so we are just trying to look at some of the properties and the relationship that we have in the definition of our number theorem. So property like divisibility, prime numbers, prime factorization, and so on, based on what I've shown earlier. And let me back it. So this property is what I'm talking about. So all these properties, divisibility, prime numbers, prime factorization. So we have greatest common divisor. Greatest common divisor is what we know already. That is our ACF, highest common factor, that we are familiar with. Just that you can also call it this particular name. So we also have LCM, ACFI. Greatest common divisor is the same thing as ACF, highest common factor. So, and modular arithmetic is part of what we are going to consider later on. So after, it will be covered under number theorem. It's a concept to be looked into. So congruence relationship also is used in modular arithmetic. So number theoretical function. So now, where we stop, we actually stop in binary numbers, because we look at number base. We know that this number base has to do with numeration system, or we say what numeral word system. So, and this word system can be in different base. We can have a number in base 2, base 3, base 4, and so on. So we try to point out some common word base. So like talking about a number in base 10. So number in base 10 is known as decimal, or we call it dinary. And a number in base 2 is what we call binary. And a number in base 8 is octal, while a number in base 16 is hexadecimal. We are trying to look at those one that has more significant application to what we are doing, or what we are about to do. So we could have in some other words base like 3, 4. They also have their own special name. So that is that for that. So we are going to continue from where we stop. We've already looked at how to, because we try to consider binary numbers, meaning number in what? In binary system. And in this system of numbers, we get to know that what? We only have 2 numbers in such system. The word bi means what? 2. So the only numbers we have in binary system, there are 2, which are what? 0 and 1. So for instance, if we say what? Base 2, for instance, a number in base 2. So we should know that we only have numbers less than that word base number in that system. So if we want to talk about the set of numbers or the range of numbers in that system, it's going to range from 0 down to that particular word base number -1. So if I say it's going to range from 0, now it's going to range from 0 down to the base number. Let's say we have a number in base m, for instance, a number in base m. So the number we are going to have in this system that we have in base m is going to range from 0 down to m-1. So if we have a number in base 2, for instance, a number in base 2 now, so that means those range of numbers that we are going to have will be what? 0, 1. If it is what? Base 3, for instance, base 3. So the number we are going to have will be what? 0, 1, 2. So it's going to range from 0 down to 2. So I believe we understand that. So we look at what? Binary number, then we start looking at arithmetic what? Operation on what? Binary numbers. Talking about addition, subtraction, multiplication, and division. We were able to what? To cover the addition and the multiplication. And now, for instance now, okay, let us look at some multiplication questions. So, and that one will cover what we learn in addition. Because there is no how we multiply that word. We won't add in order to get our answer. So, let us look at some questions here on multiplication. We are going to solve it together. So this one is just like a review of what we've done in our previous class. So now we have a question. So the first question we want to look at says multiply the binary number numbers 1101 and 1001. So that is what we want to do now. Now, solution. We have 1101 times 101, because that is what the question asks us to do. We have to multiply. So now we need to arrange this number. So it's going to be 1101 times 101. So this is how the arrangement will be. Remember, number that has the same place value should fall under one another, right? So that is why this one falls under this one. This one falls under this one because they have same place value. But if you should miss the place value, there will be a problem because your answer will be wrong. Now let's multiply. It's still the normal way we are used to in multiplying. So let's do the multiplication. The first number here to the right hand side, we multiply everything up here. Now let's do it together. 1 times 1 give us 1. 1 times 0, this times this times this give us this. So that means if this one multiply everything up here, we still have that same numbers. Now it's now the turn of this 0. It's now the turn of this 0 to multiply. So now, is 0 will multiply everything up here also. Is 0 times 1, 0. 0 times 0, 0, 0, 0. So everything there is 0. Now we'll multiply again by this 1. So we'll multiply again by this what? 1. We'll use that 1 to multiply everything up here. So now, let's do it together. So this 1 times this, we have 1, 0, 1, 1. So now we need to add for us to get our final answer. Now, this one will come down. 0 plus 0 is 0. 1 plus 0 plus 1 is 2. But we can't have 2 in base 2. The only number we can have in base 2, they are number that is less than what? 2. Which are what? 0 and 1. Excluding what? Negative number and number above what? 2 and 2 itself. They are excluded. So now, 1 plus 1 is 1 plus 0 plus 1 will give us what? 2. So if we want to know our answer, that 2, we are going to divide it by the base number. So what is the base number here? Is 2, because each of those numbers, they are in what? In base 2. So we'll divide this value by the base number, which is 2. 2 divided 2, what will it give? 1 remainder is 0. So is this remainder we are going to put down here? So that means 1 plus 0 plus 1. Everything that we have here. Everything that we have here. Everything that we have here. We have it to be 2. But we are going to put it down as what? 0. So yeah, I'm going to write 0. So what are we going to do with this one? Because what we just put down here is the remainder. So this one will be transferred to the next number. So I will transfer that one to this next number. So this is the one here. So I'm going to add everything all together. 1 plus 1 plus 0 plus 0. What will it result to? 2, right? And 2 means what? 0 carry 1. So we write down 0, then we carry 1. So this plus this also give us what? So it's going to be 0 carry 1. 1 plus 1, 2. So it will be 0 carry 1. So this will be our answer for this particular question. Please, do we have any question? No question, right? So that means you will see that this question covers both multiplication and addition. We must always have it in mind that there is no how we multiply that we won't go back to what? Addition. So let's pick another question. So for question 2, what we want to do is this. The question says we should multiply. Let me go for another question. Pardon me. So the question says we should multiply this. 1, 0, 1, 0, 0, 1, and 1, 1, 0. Both numbers in base 2. So now, it's going to be 1, 0, 0, 1 times 1, 1, 0. So it's equal to. Now let's simplify together. So after arranging this, what I have. Now, 0 will multiply everything up here. So we have 0, 0, 0, 0. Now, it's not the turn of this one to multiply everything up here. It's a turn of this to multiply everything up here. Now, 1 times this. You will see that if 1 should multiply anything, it will return that value back, right? So, when we get to binary operation, there is what we call identity element. We will understand that what? Identity element, when it comes to multiplication, is 1. And when it comes to addition, it is what? It's 0, when we get to that concept. Now, this one, when it multiplied what we have up there, it will still be that same value. So now, we are going to have this 1, 0, 0, 1. you will observe that there is a shift. Anytime we are writing our answer, there is always what? A shift, like shift by 1. We just shift inward by 1 step to the what? To the left hand side. Now also, if this one should multiply also, we will still have that same value. So we have 1, 0, 0, 1. So now let's add together. So now, what will this one, what will it result to? This 0 will move now, right? 1 plus, 0 plus 1 is 1. 0 plus 0 plus 1 is still what? 1. 0 plus 0 plus 0 is still what? 0. 1 plus 0 is what? 1. And this one will move down. So the answer for this is what? 1, 1, 0, 1, 1, 0 in base 2. So now, that is the solution to that. Now I want you to what? To attempt this question shortly. But before you attempt that, now let's assume that we have this number 5. If I have 5, this 5 is not a number in base 2, and it's not even possible for us to have 5 in base 2. Now if I now ask you this 5, what will be the value of 5 in base 2? What will be the representative of 5 in base 2? How are we going to get that? We can get that. So you rather what? If we assume that this 5 is in base 10, because the base of that 5 is not what specified here, so it will be assumed that what it is what? Base 10. So one thing will come to our mind, we divide repeatedly by what? By 2. And as we are dividing, we record down the remainder. And the collection of the remainder give us what? The answer. Or probably you can also what? Figure it out in another what? Way. Like I want this 5 in base what? In base 2. So what I just need to do is that 5, I will divide it by 2. So when I divide 5 by 2, what will it give me? It's going to give me what? 2 remainder 1. I need this 1, right? So I'm going to write this 1 down. This is the 1. Are we together? This is the what? The remainder 1. So these 2 that we have here, you know, the concept is you will carry it, right? But these 2 also, we can't have 2 in what? In base 2, right? So we need to what? To convert to know what will be the equivalent of these 2 in base 2. So it's going to be this value 2. We are going to divide it again by 2. This value here. We'll divide it again by what? By 2. So 2 over 2, what will it result to? 1 remainder 0. So this other one, I'm going to write it here. So this, is 0. Pardon me for that mistake. I'll be writing 0. Then this one will be carried. So the one that will carry will be what? Will be here. So the equivalent form of 5 in base 2 is what? 1, 0, 1. Though I can write to indicate the base and specify it like this, 2. You can either write it in figure or in words, but I prefer what? Using what? Word than what? Figure. Because sometimes if you should write if someone should write 1, 0, 1 and 2 like this, this 2 here is not a base. Because it's in line with what? This 1, 0, 1. So if I want to use these 2, if I want these 2 to be what? Seen as a base, it will be written as a what? Subscript. So it's going to be 1, 0, 1 base 2 like this. So I will prefer this word, this format. So here now, this is the value of 5 in base what? In base 2. But there's a way we can what? Confirm that, right? By we what? Taking this one back to base 10. You know, there is one way that I used to explain using the word, the weight, right? To multiply each digit word value, right? So if I may ask now, I didn't know, maybe you guys can still remember. So what should be the weight of this one? The weight of this first one should be what? Should be 1. This one will be what? This one will be what? 4. Now, why we have the weight to be like this is all because, we are dealing with what? Base 2, right? So the first number to the right hand side, the weight of that number will be 1. So subsequent what? Weight will just be what? Times of that what? Base number. So if I multiply 1 by 2, I will have 2. If I multiply 2 by 2, I will have 4. So that is how you keep getting what? Those numbers. That is how you keep getting what? The numbers. Please, do we get that? So now, if we now want to be sure whether this value that is written here for 5, because this 5 now, it will be assumed to be in base 10. This is the equivalent form of it in base 2. So we want to show whether this value is actually a representative of this in base 10. So we've already know this concept, like placing the weight, like the place value up here. So each of these weight will multiply the respective digit value. This 4 will multiply 1. 4 times 1, I'm going to have it like this. 4 times 1 plus this times this, that is what? 2 times 0 plus 1 times 1. 1 times 1. So if we should multiply this, the idea is it must give this value back. So if it didn't give us this value back, that means we are wrong with our simplification. Please, do we get that? Now, what is 4 times 1? 4. Plus 2 times 0 is what? 0. 1 times 1 is what? 1. So 4 plus 0 plus 1 is what? Is 5. Is 5, which is the same thing as this value. Do we get that? So that is that for that. So I want to give you a question to what? To solve. Before we move to division. So you are to multiply. You multiply this number 1, 1, 1, 0 and 1, 1, 1 together. So both numbers are in base 2. So the time starts now. Okay, now. So now let's look at the solution of this together. Solution. So we have 1, 1, 1, 0 times 1, 1, 1. So we want to multiply these two numbers. We have those two numbers in base 2. In base 2. You remember I said something that before we can say we can multiply direct or we can consider an operation on a particular numbers, it must be that the numbers, they are in same base. Because for some question, you can have one number in base 2 times a number in base 3. There are some questions like that. So the idea is what? You first convert each of the number to same base, like a common base. That common base will be what? Base 10. So after you solve the two numbers in base 10, you first multiply in base 10. You will now change the the answer back to to base 2. But here now, the number is already in in base 2.
Why do you not change it back to base 5? No, now. Yeah, you get 6 plus 3. Do you understand?
No. It depends on
Because you convert with
the question. In such question, there will be an instruction that leaving your answer in so base. It could be base 3, base 2, it depends. So the instruction will be stated in the question. So back to this question. So we have this. So now, we'll first start with this one. It will multiply everything up here. When one multiply anything, it will return that same thing back. That is why 1 is seen as an identity element under this operation, multiplication. So now, or we can call it a neutral element. Now, 1 times this is 0, 1, 1, 1. So now, 1 will also multiply. We just know that we are going to have that same value for each of the what? The lines. But one thing is, they won't be in the same position, right? There will be a shift to the left-hand side by a step. So here we have 0, 1, 1, 1. 0, 1, 1, 1. Please, do we have anybody confused for this? Okay, now, here we have 0, we have 1. 1 plus 1 plus 0, that will be what? Is 0, carry 1, right? Now, I probably want to give you something like this. It's on purpose. You will see that I explain something using 5. That 5 is what? Is in base 10. So that explanation, I want to actually know whether what you actually understood the word explanation or not. Now, 1 plus 1 plus 1, everything there is what? 4, right? But we can't have 4 in base 2. So what do we need to do? We have 4, right? We can't have 4 in base 2. So we'll divide that word 4, that is the result, by 2. So what will it give us? 2 remainder is 0, right? Now, these 2 also will divide it again by what? By 2. So it will be what? 2 over 2. 2 over 2 is what? 1 remainder is 0. Now, but we can have 1, right? In what? In base 2. So the answer is going to be 1, 0, 0. 1, 0, 0. But you know one thing? I know. I've convinced you. Pardon me for that. Now, this is what I'm going to what? To stop. So when we divide 4 by 2, what does it give? 2 remainder 0, right? So we are going to write down the remainder here, is 0. And do what with these 2? We'll carry that word 2, right? So 2 plus it, we have 4, right? So what will it give? Is 0, carry what? 2, right? 2 plus 1, 3, right? But we can't have 3 in base 2, right? So that 3 we divide it by 2. What will it give? 1 remainder 1. So you write your word, your remainder, then you transfer this one to the next number. Please, will we get it?
Yes, no.
So the answer is what? 1, 1, 0, 0, 0, 1.
Please now.
Please, will we get that?
Yes, sir.
We understood, right? So that is that for that. So now, before we look at division of number base, let us look at how to make conversion from base 2 from binary to decimal. So let us look at that. Now I want to look at this conversion from binary to decimal. So this is what we want to look at. We want to look at conversion from binary to what? To decimal. You are only what? Explain somehow. But I've not explained in detail like that. So now, looking at the conversion, for instance, let me just use your question to explain. Let's say we have to convert, let's say we have to convert 101101 in base 2 to binary. Binary is still the same thing as what? Decimal. So any of the two, it means the same thing. Or we could have it like what? Convert this to base 10. That one is straightforward. Now we want to convert this to what? To base 10. So I will use 2 ways to explain. One of the ways, the shorter way I explained earlier, using the weight to multiply each word, digit word, value. Now let me start with that. So solution. Now I have 1 0 1 1 0 1 in base 2, right? So it's equal to Now let us use what? The place value what? Concept. So now, this first value here now, what will be the what? The weight of this. The weight of this first value here will be what? Will be 1. So the next one will be what? 2. Next one, next 32. So the idea is the first value, like the first digit to the right hand side, we take value 1 to be his what? Weight. So that is the unit, like the unit. You know, if you are working in base 10, we have 100 tens and unit, or we could have 1,000, 100 tens and unit. So the unit is 1, but here we are not working in base 10, it is base 2. So each word, each value will differ by what? By 2. Differ in the sense that it will be times 2 of the previous value. So if I have 1 here, the next one should be what? 2 times heavier than this. That is 2 times 1, that is 2. So the next one should be what? 2 times the previous value, 4. So that is how we arrive at what? 32. So each of these values that we have here, the weight, we multiply the respective what? Positional what? Digit what? Value. So 32 multiply what? 1. So here we have this. 32 times 1 plus what? 16 times 0 plus what? 8 times 1. You can see this multiply this multiply this. I didn't know, maybe you can see what I'm saying. This times this times this, this times this, this times this. So it's going to be plus 4 times 1 plus 2 times 0 plus 1 times 1. So now what is 32 times 1? 16 times 0. We have 8, 4, 0, then we have 1. So the addition will be what? We have 40, 44, that is what? 45. So we have it to be 45 in base 10. We might just write 45. So if it didn't indicate the base, that shows that what? It is in what? In base 10. That's the question.
Like, I'm just looking at, she said the stress
Okay.
of all of this. Like, the moment you put the weight on top, 32, 16, you can just pick it from there.
Yeah, we'll just neglect, you will just neglect the zero. Just consider the one that is with no zeros. So that is, I'm just trying to show so that everybody will see what is happening. There won't be lost that, what of this zero? How come? Why does the zero will disappear? So do we get the logic? What he's saying is that we've already know that anything times 0 will vanish. And the 0 added to anything is of no significance. So we can just neglect that and continue with what? Non-zero value. So 32 times 1, 8 times 1, 4 times 1, 1 times 1 is those values that we will not have to get that. Please, I believe you understood that.
Yes, sir.
Now another approach is what? We using indices format. Indices format in the sense that we must know that there is a number in this form. We could say this number is what? Is in index form, or we say what is an exponent number in exponential form. So the number that we have as our superscript, we call it power, or we could call it exponent, or we could call it index for this word superscript number. Why this one that is down here? We is the base, so we call that the base. So now, how can we use this word into the simplification of this? Now let me resolve it like alternative way of dealing with this, but that one will be seen as a long approach. So we have 1 0 1 1 0 1 in base 2. You know, we have base and there is no r. Once we have base, there must be something to back it up. That is what? The power. Now for instance, let's look at it from this angle. You have a foundation without a cover, Does it make any sense? If you have a foundation, the foundation should have a what? A cover. The intention is to what? To build something on it, right? Abi now. So that thing you are building on it is the what? Is the cover. That is the power. But the base still remain what? The base. Do we get the logic? Let us what? Picture it from that angle. So now, this is a base. That means for each digit value, there must be what? A power. That what? Correspond to each what? Digit value. So here now, for us to what? To know that I will what? Use the layman way. This first number here, we have power 0. This first number here, we have power 0. You then start what? Increasing that value from that 0 upward. As if you are what? Counting what? Numbers. So if I have a 0 here, the next value should be what? 1. The next one should be what? 2. The next one 3. Next one 4. Then next one 5. Do we get the logic? Or probably if you didn't want to show these were values, 0, 1, you might say that what this concept is what? Childish. You can just picture it like this. How many digits number is this what? Giving number? We have 1, 2, 3, 4, 5, 6. This number that is given to us there, how many digit number is it? 1, 2, 3, 4, 5, 6. It is what? 6 digit number. So if you want to know the highest power, starting from the left hand side, the left hand side will be what? From this angle, right? Just subtract 1 from the number of digits. Number of digits is what? 6. Number of digits is what? 6. Subtract 1 from it. What does it give? Give us what? 5. So that means the first number to the left hand side, the power will be what? 5. So since you know the power of the first one, you now start reducing it by 1 as you are what? Progressing to what? To the right hand side. So you subtract 1 from 5, give us what? 4. 1 from this 3 till you get to what? 0. So now let us write down the expanded expression for this. So the expanded expression is going to be this first value, you write it down, which is 1. I have 1, so the 1 is here. The 1 is here. So this one here, we are going to multiply by the base. Because the idea is what? Each of these values will be multiplied by this format. But this format is going to be the base to the power that corresponds to it. The logic is what? Each of these number, like 1, 0, each of these will be multiplied by this. But this A will be known, S will be known. Our A is going to be what? These 2. And our what? Our X will what? Will vary based on what? Position. For this what position, our S will be what? 5. For this position, what will be our S? 4. For this one, 3. For this, it is what? 0. So let's do it together. This first value is what I'm writing here. I will multiply it by this. That is what? Times 2 to the power of 5 plus the next value is 0 times 2 to what power? 5 plus 1. Oh yeah, now just help me out.
2 to the power 3. 1 to the power 2. 0 to the power 1.
Plus 1, 2 to the power of 0. Please, do we get that before I can continue?
Yes.
Now, that is 1 into bracket. 2 to the power of 5 is what? Now, is what?
64.
64. Okay? Someone says 64. There's nothing wrong. I don't want to get something. Maybe we actually what? Understand 2 to the power of 5. Someone said what? 32. Now, let me just what? Explain something briefly. Now, if I should have this, for instance, 2 to the power of 3. Power is there to tell us something about the base. Meaning the number of times we have to multiply the base. So, what is the power here? 3. And the base is what? 2. So, we have to multiply 2 to itself. How many times? 3 times. So, this one simply means 2 times 2 times 2. It's just a shorthand way of writing 2 times 2 times 2. So it's become 2 to the power of 3. So now if I have, for instance now, I have 2 to the power of 5. So what does this one mean? This one does not mean 2 times 5, because some of us will still keep making that mistake of multiplying the base to what? To the power. No. What it means is what? Multiply what? This base, which is what? 2 to itself 5 times. That is 2 times 2 times 2 times 2 times 2. 2 times 2 is what? 4. 4 times 2 is what? 8 times 2 is what?
16.
Times 2 is what? 32. That means 2 to the power of 5 give us what? 32. So here we have 32. Plus, though we know that anything times 0 will vanish, right? So should we show it, or okay, let me show you. It's 0 into bracket 2 to the power of 4 is what?
16.
Plus 2 to the power of 3 is what?
8.
2 to the power of 2,
4.
2 to the power of 1,
2.
and 2 to the power of 0.
1.
Are you sure?
Yes,
Sir.
Very sure.
Yes, sir.
Final answer.
Yes,
Yes,
sir.
sir.
Now, we must always have it in mind that any number to the power of 0 is what? Is 1. Now, let me what? Test your what? Let me test you. I have this, 2 to the power of 0. And I have this, minus 2 to the power of 0. And I have this, minus 2 to the power of 0. What is the answer in each case?
1.
The first one is 1. The second one is what?
1.
Are you sure?
Yes.
The way you are sounding, you are not sure.
We are sure.
Okay, now, we will assume that you are sure, right? You said what?
I know.
1. The last one is what?
1.
It is also 1.
Yes. Minus 1.
1 or minus 1?
It's 1.
One.
Wait, it's 1.
The answer is what? Minus 1.
One.
It is minus 1, not 1.
When they talk us to, they say
It's
anything.
anything.
Now, yes. There is something you are not getting.
Minus
Now, let me what? Make it clear. Now, here, you will discover that for this first case, for this one, this 0 is what? Is in direct contact with that 2. For this, you will see that what is what we have in the parenthesis that is affected by that word is 0. And we have both the negative and the 2 in the parenthesis, right? So that means anything in that parenthesis will be seen as 1. But look at this one. This 0 is in direct contact with what? 2. He has no business with what? The negative. So that power 0 is only applicable to what? To the 2, not what? The negative. So 2 to the power of 0 is 1, but the negative will still remain there. So that is how it becomes minus 1. So that is that for that. So here now we have 1 here. So now, 1 times 32 plus 0, 1 times 8, 8, 1 times 4, 4, plus 0 plus 1. So when we add everything, you will see that I still come back to what? 45 in base 10. So this is how to what? To make conversion from any base. You might be given a number in base 3 or some other base. So just have it in mind that anytime you want to move from base, any base to base 10, this is how you what? You will solve it. Do we understand?
Yes, sir.
We get the concept right. So now, let us try to consider what? A number in what? In base 8. Octal what? System. Let us try to look at what? But before we consider that, the idea is to what? To explain what? Division of what? Binary what? Numbers. So let us quickly what? Explain the division of binary numbers before moving to octal what? Numbers, that octal system, and what? Hexadecimal what? System. But with what we've what? Discussed so far, just know that what is happening in base 2 is still same thing that is happening in what? All other base. The way we are doing the simplification is still what? The same way in all other what? Base. So now we want to look at division of binary numbers. Division of binary numbers. So division of binary what? Numbers. So now let's look at some questions here, because why I explain this, why I explain conversion to base 10 is for us to what? To be able to implement it in division. Because for some division question, it will be easy for us to what? To simplify sum, because it is somehow logical. So that is what I want to explain. We converting to base 10 whenever we are dealing with what? A number in what? In base 2, like division of numbers in base 2. So here now, the first question we'll look at is, the question says, divide the binary number 110,101 by 101. So now, let's solve this together. Solution. We are to divide the binary number this by this. So this is what it means. 110,101 is to be divided by 101. So that is what we want to do.
Yes.
So you know, there is a concept, one long division what approach. Let me start with that. You know, if I should have, for instance, in base 10 now, if I have 5/2, the idea is we'll draw this with square root symbol. And you know, the number down here will be placed outside, right? This number down here, we call it the divisor, right? And the one that is up here is the dividend. So we have 5 here. But later on, I might later refer to this one as multiples and this one divisor. So, but let us what? Take it like in a name mark or 10. So I will what? Refer this one as what? Divisor, because it's the one that is dividing the one up, which we call the dividend. So yeah, we know how to simplify this. So we ask ourselves, how many days can we see in this? How many 5 can we see in what? How many 2 can we see in 5? That is 2. So these 2 multiply this. This times it, we have 4. Then we'll subtract, that is 1. So for us to continue, because we know that if we want to continue these same numbers, we'll ask ourselves, how many of these can we see in this?
0.
But one thing is, this one is more than this. It's not possible. Pardon me that what? I'm just trying to, I want to ensure that yes, we have a proper understanding of what we have been doing all this while.
Yes, sir.
Because one thing is, majority of us, we are lazy because of what? Calculator.
Yes.
We didn't even bother to say that, why is what? 5/2? 2.5. We never will bother about that. So this one is just trying to explain why. Now, this one, we ask ourselves, how many of 2 can we see in 1? It's not possible. It's not making sense. Making sense is a sense that this 2 is more than this.
Of course.
That is why I said what is not making a sense. So yeah, what we now need to do to what? To bring our sense in this word nonsense is what we what? Introducing what? Point. So yeah, we will introduce a point here at the back of these 2. So because of this word point, we will place what is 0 at the back of that one. So the new number here in this position is now what? 10.
10.
So now, we will now go again. How many 2 can we see in 10?
5.
5. This 5 will now multiply the 2 back.
10.
5 times 2 is what? Is 10. So we subtract. So we have nothing left.
Yes.
So that is how we have the answer to be 2.5. This answer is what we call quotient. So I will explain more on that when we get to polynomials.
Today.
Not today.
This is the people.
So I will get to know how what polynomial was being applied in cryptography as well. So here now, this is the division we have. So let's first of all consider we solving it in this form. Maybe we can come up with something interesting or not. So now is equal to, but this approach for this is logical. So now we'll have 1 1 0 1 0 1 in here, right? And 1 0 1 will be outside. That is what we want to use to divide. So how many this can we see in this is a problem.
Plenty.
It's plenty.
Yes, very.
Very plenty. Someone says it's plenty. Very plenty. So which one are we going to hold? We didn't know, right? So and another thing is, we didn't know maybe this one is actually a multiple of this.
Yes.
Multiple in the sense that it can divide in this perfectly. You understand? So now here, and we can't just consider it based on digits and say this one is what? Is 2 digits, right? Is 3 digits, sorry. And this one is what? Of more digits. Like this one is what? 6 digits. So maybe trying to consider it 3 digits to 3 digits, and you keep reducing it like that. So let's try it like this. Let us what? Be playing with numbers and multiplying with this. Okay, you didn't want this approach.
No, don't say
It's long.
It looks like it's going to be long.
No, it's not long though, but it's logical. You just have to know how to find your way around it. Now, let us try something before we what? We complement it with the base 10 approach. So here now, let us play around by multiplying 101 by what? Numbers. So the number we use to multiply that 101 will be in base 10. But our answer will be written in base 2. Now, we have 101. Let's assume that this 101, I choose to multiply. I'm just guessing now. It's more like a what? Try and error method. Try and perfection method. Do you understand? Now, let me just multiply. Let's say I decide to multiply this number by 5, for instance. Now, what is 5 times 1?
5.
5. But the intention is I want my answer in base 2. So, I can put down 5 here as my result.
Yes.
So that 5, I will divide it by what? By 2, which is the base number, right? So what will it result to? 2 remainder 1. So what will I write here? I will write 1. Carry what? 2.
So the 5 could be a random number.
This one is just a guess.
Like this scenario.
This one is just a what? It's a guess. Do you understand? Now, this times this now, I have 0, right? So these 2 will be added to that 0. So we have 2. Now, can we have 2 in base 2?
No.
We can't have 2 in base 2. So what do we need to do? We divide that 2 by what? By 2, right? That is 1 remainder.
0.
So what will I write?
0.
Carry what? So 1 plus 1. Oh, sorry. Mistake. 5 times 1. 5 times 1. We are multiplying. 5 times 1. 5 plus this value that we carry, 6. So now, that's 6. We can have 6 in base 2, right?
Yes.
So what do we need to do?
Right.
So that is what? 3 remainder.
0.
So I will come here and write what?
0.
And carry what? 3, right? 3 in base 1, in base 2 is what?
1.
1, 1. It is what? 1, 1. That is 11, right?
Yes.
So you can see what we have here. Is this value, is it up to this? How many digit number is this? 6. This one is what? This one is what? Is 5.
Which one? I don't see
This one that we have here, how many digits it is?
5.
It is 5. How many digits is what? This one, 6. So it's still far away, right? So let us increase the value. I'm making a guess here, right? Now, we want to know how many of these can we see in this. So let's multiply by, let's try 6. Let's try 6. So 6 times 1 is what? 6, right? So what will it be? 0, carry what? 6 times is 0. It is what? Is 0 plus 3. That is what? 3. So it will be 1 carrying 1, right?
Yes.
So what are we going to have now?
6 times 1.
6 times 1, 6 plus 1, 7. So now we have 7.
Yes.
So what will it be now?
1.
So it will be 3 remainder 1. So we write 1, carry what? 3. And that 3 in base 2 is what? 1, 1. So how many digits value is this? How many digits? It's still 5, right? So let's try.
Good question. Now that we are like, we're just multiplying the random numbers.
Yes.
What if the end product of the coefficient has
A remainder. Yes. It's a good question. We are coming there. So probably we might discover that what?
What is called coefficient to?
What is what?
Coefficient.
Coefficient is the what? Is the result. The final answer. Like this one.
I'll still have remainder.
Like this one. No. Look at something here. Look at something here. Let me write something down here. The logic is this. You have a number here, a number up here, a number down here, and you are expecting a result, right? This number up here, we call it numerator, as we all know, or we call it dividend.
Divisor.
And this one, denominator, or we call it divisor, right? This one is the quotient. But there are some scenarios where we have remainder. In that scenario is when what this one is not a multiple of this.
Of course.
Meaning this one is not fully divisible in this.
Yes,
It can't divide this. So we are expecting a remainder. Now look at this was setting now. This arrangement.
Mention coefficient. I don't see
I'm coming. Coefficient.
You mentioned it.
Quotient. I said quotient from my hand. Now from here, these are dividend, divisor. This is the answer we are what?
Yes.
Expecting, right? And what we have here is the what? The remainder. Yeah, I use that dash, meaning no remainder. But you won't say no remainder. The remainder should be what? Assumed to be what? 0. Nothing is what? Is assumed to be what? 0. So in set theory, when we get to set theory, if you have an empty set, we can have an empty set. And an empty set, now, if you are talking about the cardinality, meaning number of elements in a set, is what we term cardinality. So now, back to this.
We're enjoying it.
Are you sure?
So now, let's try to multiply by 7.
Let's go to 12 now.
No. Let's take you. Let's take.
You cannot rush this.
What?
Life is not rush.
Now, 7 times 1 is what? To me, I would prefer using the base 10 approach.
2.
Yes, you mentioned
The base 10 approach, because this, if you are not careful, at some point you will be lost. But the way I'm explaining it, you won't be lost though.
Amen.
Okay, just to Professor, just to ensure that I'm on the right track. I just
Okay.
want to ask. So, what's the purpose of us starting with these numbers progressively?
Okay. The purpose is we want to know how many of these
Have you seen that?
can we see in this. If truly this can divide in this. You get? Like for instance, if I have 4 over 2, what is the intention? You want to know how many 2 we can see in 4, right? So you will say what your answer here is what? 2 remainder 0. You get? So if I have 5 over 2, I mean, you know, here 2 can go in 4 perfectly without leaving nothing, right? But we assume that the remainder is what? Is 0. But here 2 cannot go in 5 perfectly. But we can just see what? Some 2 in 5, right? Something will be left. So it's going to be what? 2 remainder 1. You get the logic? So we want to know how many of these, if at all there will be remainder or there might not be remainder. We just want to know how many of these we can see in this. But you might be saying that the number that should multiply this should be what? A base 2 number, right? But we are using a base 10 number. So that base 10 number, we just want to use it to get the value. We'll still later convert it to base 2. You get the logic now? So,
Wait, no. That is 10 number.
yes.
That is to multiply. Like
Yes.
it's 5, 7.
Yes.
We will not cover that 7 with base 2.
Yes. So,
Like if
Because like currently this number itself is in base 2, right? Currently this number itself is in base 2.
which one?
The one that, yes, this one that I'm trying to divide, finding out
Yes.
is in base 2.
Both the number up and the one down, they are all in base 2.
And now we're using base 10 number
To multiply.
To achieve the purpose, we still have to convert it to base 2.
Yes, you will notice that our answer here, we have it in base 2. But this one is in base 2. But this one here is not in base 2. You get?
The 5 itself
This 5 is not in base 2. But this one is in base 2 in the sense that, but the multiplication is considered in base 10. But if I say this one is in base 2, in the sense that we have the 0 and 1, you understand? But the multiplication is considered in base 10. But instead of writing our answer in base 10, 5 times 1 should be 5. So I put down what 1 instead of that.
So that's instead of the conversion.
Yes, meaning I'm taking my answer
Base 2.
in base 2 instead of what? Base 10.
It's not as if
Yeah, good question.
that separate conversion.
my brain was ignoring it.
Okay.
Like, no, when you want to do any addition, subtraction, or division, you're supposed to do it like base 2, base 2, base 10, base 10.
Yes.
What's the beginning of us doing base 2, base 10, multiply by base 10?
Okay, thank you. Now, I'm just trying to tell you that, yes, that is a contradiction to, I won't say contradiction. You get? I won't say contradiction. In the sense that this number here
Yeah.
is not in base 2, it's in base 10. This one too is also in base 10. So instead of me writing the answer in base 10, I'm now writing the answer in base
I have
2.
another question. So if one
Sorry, let me clear that. Let me first clear that first. I'm the one that said what? Before we can say we can have a direct multiplication or direct addition or subtraction or division, it will be that what? The number involved, they are in same base, right? So that is when we can what? Simplify direct, right? But in a situation where we have the first number in base 2, the second one in base what? In base 3, we can what? Multiply direct, or we can add or subtract or divide direct. We need to first convert everyone, all the word, the number, each numbers to what? To same base, like common base, which is going to be base 10. So is that base 10 answer, you now convert back to whatever base that the question instructs us to what? To express our answer. Now, your second question.
The one I asked, that's not the problem. It's just what is the problem.
Okay.
The problem now is that we're trying to see if how many 1 can we find in what is inside.
Yes.
And you said that our 1 here is not in base 2, it's in base 10.
Is it this one?
Yes, the one I want to multiply by 5.
This one?
Yes, no. Yeah, it's still 1.
This one, everything here is in base 2.
Yes.
Both of them.
But the one
But
I'm
yeah.
asking for, the one I multiply by 5, you said it's not in base 2, it's in base 10.
Yeah.
Which implies that 1 here is not equal to 1 there.
Okay, now,
Now,
let me make clarity now. Now, have it in mind that a number in base 10, for a number in decimal system, the possible or digit that we can have in base 10 are what? 0, 1, 2, comma, dot, 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 comma, what? 9.
Yeah.
You agree, right? And for base 2, possible number we can have in base 2 is what? Is 0 and 1.
Yes.
Abi now? Now, if I should have this number, for instance, 101 in base 2, I have 101 what? In base 2, right? So now, you know that we can have 1 and 0 in base 2, right?
Yeah.
Also in base 10, we can also have 1 and 0 in base 1, in base 10,
Yes.
right? But now, I get your point. This one now, if I say is not in what? In base 2. There is a kind of what? Biasness in my statement. So let's see, assume that is in what? In base 2.
Sorry.
Wait. No, I'll prove my point. Now, let me prove my point from here. Let me prove my point from here. So we have 101, we multiply it by 5. You know, this 5 here, there should be a value that represents that 5 in base 2. That is 101. So if you want to agree with me, if you should what? Arrange the what? The weight. Here will be 1, 2, and what? 4, right? 4 times 1 is 4. 1 times 1 is 1. So when you add, we are neglecting this because of the 0, right? So it's 5, right? So this one is still the same thing as this 5 here. So this one is trying to tell us that 101 in base 2 is equivalent to 5 in base 10.
So if that's the case,
yes.
Sorry,
yes, we are learning now.
If that's the case, then that 5 has been our base, like to be checking. No, now no, we are moving from 5, but I'm checking 7. I'm checking. Exactly,
we are making a guess. We want to know how many of these can we see in this. But you know, if I should pick this one, 101, that is in base 2, to multiply this value that we have in base 2, to multiply this value that we have, if I pick this one, which is in base 2, right? Which is the 5 in base 2, to multiply this one, you know, the process will be long. After you multiply, you later add. You remember the way we multiplied. So that is a long approach. So this one is just what? To shorten it. So that is why we just use this 5 instead of what? This one. So if I should use this one times this one, you see that the answer is this. Should we what? Check it out. No. Or maybe later you can.
You are correct.
Okay.
We're trying to know how many ones
yes.
can go into
in this value.
10101.
Yes,
right?
yes.
Now you have established the details, but you have established now that maybe you want to tell us later that 101 is actually 5 here.
Yes,
right?
yes.
Well, everything still goes back to us providing the test, so just continue.
Okay, now.
Yeah.
So we want to multiply it by 7, right? So let's check it out. When we multiply by 7, 7 times 1 is what? 7, right?
Yeah.
But can we have what? 7 in base 2? No. So what are we going to write down? That is 1, right? 1 carry what? 3. 1 carry what? 3. So now 7 times 0 is what? 0 plus that 3. So and we can have 3 to be 1 carry 1, right? So 7 times 1 is what? 7 plus the 1, 8, right? So 8 will be 0, we carry 4, right?
Yes.
4 is what?
0 we carry 2.
0 carry 2, 2
is 0.
Is 0,
We carry 1.
we carry 1. That is 1, 0, 0, 0, 1, 1. So how many digits is this? 6. But is this value up to this value yet? No.
Yes.
You understand?
Yes, sir.
No, that means we will still what? Have to what?
Continue.
To check again. Maybe if you have 101 times 8, the value will be what? Beyond this. Or it will give this exact what? Value. So let's check it out. 8 times 1 is what? 8. So it will be what? 0 carry what? 4, right? So we have 4, right? 0 carry what? 2. 8 times 1? 8. Everything is 10. So we have 0 carry 5. 1 carry what? 1 carry what? 2. 0 carry what? 1. So it will be 1 0 1 0 0 0. So it seems this one is much closer, right? Or is it more than? It still was 6 digits.
Yes. It's not.
So it's not up to. Let's try 101 times 9. 101 times 9, what will it be? 9 times 1.
9.
So that is 9. So what are we going to have?
4.
1 carry what? 4, right? So 4. So it will be what? 0
carry 2.
0 carry 2. So we have 11, right?
11.
So that is what? 1 carry 5.
1 carry 2, 0, 1.
1
Carry 2.
0 1.
Carry 1.
1 0 1 1 0 1.
Never reach.
Okay. If you multiply by 10. Sorry? Let's multiply by 10 and see. We have this 0 0 0 1 0 1, right? So it's 0.
Wait, okay. We're trying to confirm the number that we use to multiply that will give us the exact number. That will give us this exact number.
Yeah, it might be exact or it might not be exact. There might be a remainder or not.
I think base 2 multiplication.
But this 10 is far from.
Supposed to be 10.
It should be 10 times, right?
Yes.
Sorry?
10 times 1.
So
1, 0, 1.
we have
1, 0, 1. Why is that one still?
we have what 1 0 1 times 10, right?
Yes.
Now 10 times 1.
10.
So what are we going to have? 0 carry 5, right?
Yes.
So 5 is what? 1 0 1, right? So what are we going to have?
But let us go simple.
Let's follow the normal approach.
5 is 1. You carry.
So 1 carry what?
Carry 2.
Carry 2.
That's 12.
So we have 12.
That's 0 carry
0
6.
carry 6,
0 carry
0 carry what? 3.
3.
That is what? 1 1. 1 1 0 0 1 0. Wait. Is it?
You never reach you. Never reach you.
But one thing is, if you should add this value to this, you will see that it is. Okay, let's add. Let's see. 1 0 1. If you had,
Okay, it did not be
that
11.
one will be 11.
Thank you.
So it will be 1 1 1 0 1
Now
1.
don't pass.
Which is more than. So we are going to stop at what? 10. So this 10 here is in base. Is in what? Base 10, right?
Base 10.
We'll convert it to base 2. So if you want to convert it to base 2, we are going to be dividing continuously
That's
by
1
2.
1 0 1 0.
2 in this, 5. Remainder what? 2 in 5.
1 0 1 0.
2 in this, 1 remainder. So you go again. 2 in this, 0 remainder 1. That is 1 0 1 0. That is 1 0 1 0. So this value now, when you multiply this, what will it give? We give us what? This value. We give us 1 1. Sorry? Times. Is it times 10?
0 1 0 0 1 1.
The one we are
Before we
considering.
add it up, before we add 1 1 to it.
So is it 10 we consider? This value is more than now. Is this one that we'll consider?
11.
No.
See, the one
Before
for
we
10
added
is 1 0 0 1
that
0.
10, we converted it to 10.
Sorry.
It's 10.
When we wait. This 10, when we multiply 10 to this value, it results to this, right?
Mark less.
This value, it results to this.
No. The one up. The one up results to.
It results to this, right?
Yes, that's not.
Okay, this one is 11, right? Okay. That means there is no mistake. So we have it to be 1 0 1 0, right? So when this value multiply this value, so it's going to result to this value. That is 0 1 0 0 1 1. So we'll subtract here. So we have 1 here, right? So yeah, 0 minus 1, is it possible? So we'll borrow 1 from this to this. This one will become what?
10.
It will become 2. So the idea is for everyone we are borrowing in any base, the receiver will receive it as what?
As
The
the
base,
whole
as
base.
the base number. But we know that is one we borrow. But the receiver will receive it as well, the base number, which is what? 2. So 1 from this to this will be 2. 2 plus 0 is 2. So here we have 2. 2 minus 1. So what is left here?
1.
What is left here?
0. Last side now 0.
Is 0. Yeah, right? Is 0. So we have 0 minus 0. Is 0. Is 0. Is 0. 0. Yeah, we are left with what is 0 because we follow. I mean now, is 0 minus 0 is 0. 0 minus 0 is 0. 0 minus 0 is 0. 0. Is 0, right? So all that value here, they are what? Zeros, right? So here we have what? A remainder. So the logic is this, that if we want to continue, we will need to what? To introduce point, right? Point will be introduced here. So because of this point, we'll do what? We'll add a 0. But looking at this value, is it up to this? Is this value, is it up to this? Because of this point, the idea is this: you keep what? Using this to divide your remainder.
Can you remember when we talk about numbers that base 2 and 0, 1? There's not 0, dot 1. We are adding points now.
Yes, we can have number with points. We can have bisimia. No, I don't want to complicate things. Let us please. Just endure, please.
My brain wants to. God, I beg. My name is killing me. Okay.
So now we introduce that point because we notice that this number cannot divide what we have here. You know, initially we have 11 here, right? And if you say 101, divide, how many 101 can we see in 11? It's not possible. So because of this point that we introduced, it is 11 that we have here initially. So how many this can we see in this? It's not possible, right? So since it's not possible, we need to introduce a point here. Because of this point, we add 10 here. So we have it to be 110. That is the new number. So how many this can we see in this? It's going to be what? 1. So 1 times this. 1 times this. That is what? 101. So what do? We'll subtract, right? So 0 minus 1 is what?
1.
That is what? 1. That means you've borrowed from here to here. We have 0, we have what? 0 as well. So we are left with what? 1. Have you now?
Yes.
So here now, we have 1. But this in this is not possible, right? So what are we going to do?
We borrow 2 0. No, we borrow 1 0. 4 0.
We have 1, right? So what are we going to do now?
Another 0.
So because of this point, we'll put what? 0 here.
Yes.
Not 0.
Wait. We'll put 0 here, right?
Yes.
Now, so this in this is still not possible,
Yes.
right?
Now put 0.
So we'll now introduce 10 here.
Yes.
So because of this 0, we'll put 0 here, right? Now how many things can we see in this?
No, because you put another 0.
So you put another 0 here, right?
Yes.
And another 0 here.
Yes.
Now you know one thing now.
You don't know.
Now, hello. Now you will see, I just want you to see, to reason something, that the complexity I'm talking about in what we are doing. Do you understand?
Yes, sir.
Just what, note this, what we have here, notice somewhere. Because I want to erase this. Let's try this word, base 10 word approach.
But before we go to this
Sorry that what, we are,
This life is
it's
not
not
hard.
hard.
no, you know one thing, we are here to what? To learn, to reason together, you understand? So that is the purpose of what? Bringing this. Or maybe you are going through materials and they explain this concept.
But now, at this junction now, are you going to continue to put 0?
I'm coming. At this junction, I will tell you that what? This answer is wrong. Listen. Just calm down. No, I just want you to see the logical aspect of it. Do you understand? Why you prefer it? Why you prefer what the other approach over this? But there are some scenarios that what this one you might be fine with it the way I'm explaining
Who is
it.
fine with it?
Okay.
Mr. Emmanuel, only Mr. Emmanuel is fine with it.
Okay, now I guess you guys have. Listen.
So
Have you noticed somewhere?
No.
You didn't notice it.
We noted it.
Okay.
Who noted it?
Now look at something now. A question. I'm coming.
Do you have the answer of the last before this one?
Okay. So now, so after what we just did now, so what was the result? How did you know we got the result?
Now listen.
He said the answer is wrong.
Listen.
The answer is wrong.
No. For clarity's sake, let us what jump into what the second approach. Shall you understand?
Yes, sir.
No, I just want you to reason with me. I said something that was the concept. I can put down another question that yes, I will pass my message across and you get the concept. But this one now, you can see how what the logical aspect would lead us to something that yes, that what we have been doing now, the concept work fine in base 10, right? But you see that here it's not working. It's not working. But the idea is any what concept or method that is used in any base should be valid in any other base.
Yes.
That is what the statement. Do you get it now? That is how it should be, right? So is that idea of what base 10? That is what we brought into this. And from there we see that what we are getting something what big. So now let's solve this together. So we need to convert what we have up here to base 10. What we have down here to base 10. We will use the weight approach to shorten this. Now up here we have 1, 2, 4, 8, 16, 32, right? 1, 2, and 4. So here now, here I will be neglecting what? The zeros, right? So we have 32 times 1. 32, 16, 4, then 1, right? Here we have 4 plus 1, right? So up there, what do we have? 53, right? Upon what? Upon 5. Now, the shorter way of getting this, anytime you are dividing by what? By 5. This is the logic. You should know that 5 is the same thing as 10 over 2. So just multiply the up number by 10 and the down number, you divide it by what? By 2. For instance, if I have 7 times 5, if I want to get my answer fast, it becomes 70 over 2. And we know that half of 70 is what? Is 35. Do you get the logic? I have what? 53 divided by 5, right? So this up number will be multiplied by what? 10. That is 530 over 2, right?
Yes.
So that is what? That is 2, 6.
No, not over 2, over 10. No, I did over 5 now. It's supposed to be 2 or 53 times 2.
Listen. We have 53 over 5.
Yes, that's 10 over 10.
Oh,
Define the equation.
listen. Oh, I made mistake.
Times 2 over 10.
I made mistake now.
Yes.
Now, note that what? It is very easy to divide by what? By 10, right? Now, for instance, if I should have 2 over 10, 2 over 10 is going to be 0.2. So this number that we have up here is having a point outside here. So since we are dividing by 10, the idea is move the point to the left hand side 1 times. So it will just be 1. You shifted it to the left 1 times. So the point is now here. So this place will be filled with what? Is 0. So it becomes 0.2. So if I have 5 over 10, what will it be? 0.5. Do you get the logic?
Yes, sir. Yes.
So that is that for that. So what I just need to do is find a way of making this one to be what? 10.
53 times 2.
So it means I will multiply 2 up, 2 down. So it will be 53 times 2 over what?
10.
5 times 2. So you remember these 2 and 2 we cancel out. So this will still go back to 53 over 5. So that is 106 over 10.
Yes.
106 over 10 will be what?
10.6.
10.6. We have 10.6 here in base 10.
10.
Now, one thing is, I've not explained something like this.
Yes,
Where
I'm
did
not.
106 come from?
The 106. The 106 is what? Is from 53 times 2.
I thought you said the 2 and 2 will cancel out.
No.
That is in explanation.
Do you know there is one concept called equivalent fraction, other fractions. So there are many fractions that is equivalent to one particular fraction,
Yes.
meaning they have same value but different. They represent same size but different value. Different value in the sense that what you have up there and down differs. For instance, if I have 1 over 2, you know, I can decide to multiply up and down by one particular number. Let's say I pick 2. 2 multiply up, 2 multiply down. 2 times 1. 2 times 1 is 2. 2 times 2 is what? 4. 2 over 4 is the same thing as 1 over 2.
I understand the equivalence.
3 over 6 is also the same thing. So that is what we just did here. You get the logic. Because we know that here it is very easy for us to divide by 10. Let us add the divisor to be 10. So we can easily get our answer. That is the concept. And what number will be multiplied to 5 to make it to 10? That is 2. And there is no how we will multiply what? One particular number down without what? Multiplying it up. To ensure that what? All things will be equal. If not, you just will change what is given, the given question. So that is that for that. Now this number is in base 10. This number is in base 10. And we want to take it to what? To base 2. Now, we have this number with point. So, number with point, 10.6. Number with points have two parts. We have the integral part and the fractional part. So, this part before the point is the what? Integral part. And the one after the point is what we call what? The fractional part. So what I have here, I can just split it to be what? 10 plus 0.6. Do we agree?
Yes,
so the
sir.
integral part plus the fractional part. But the fractional part will be what? 0 point or other value that what? That follows the point. Do we get that?
Yes, sir.
So that means I can replace this one with this value. That is 10 plus 0.6. This one we have it in base 10. This one we also have it in base 10. Do you get it now?
Yes.
Do we get it?
Yes.
This plus Z will give us what? This back in base 10. Please let me know because I want to round up. I don't want to finish this one.
Don't hand up.
Which one? The 10 plus
No, we want to go for a break.
Is it 10 plus 0.6? Is it 10 plus 0.6?
This 10.6, do we agree that the same thing as 10 plus 0.6?
Yeah.
You know, why I indicate the base, both of them, they are in the same base, right? Now, what we now need to do is, what is given to us is given in base 2, right? Both the number up and the one down. So we are expected to express our answer in base 2. So we will convert this one to base 2. We will also convert this one to base 2.
Simple.
But you didn't know how to convert a decimal word number to base 2. That is the issue. So that will what? Lead us to another concept. But that concept I will explain it is very simple. But you just need to pay attention. Now, so let's convert this one to what? To base 2. So if you want to convert, please.
Like everybody now.
If you want to convert this one to base 2 now, it will be done by what? By long division. Like we'll keep on dividing by 2. I'll be recording down the remainder. So I have 10 in base 10.
Before is 1 0 1 0. 10.
So 2 in 10. 5 remainder. 2 in 5.
0. 5 remainder 0.
Sorry. 2 in 5. 2 in this. 1 remainder 0. 2 in this. 0 remainder 1. So our answer for this 10 in base 10 is 1 0 1 0 in base 2. So now, so it's now for us to what? To convert 0.6 to what? To base 2. Now, for 0.6 in base 10, we want to take it to base 2. Now, this is 0.6. You should know that 0.6 is the same as 6 over 10. So, what is the operation involved here? Division. And you will see that here, we are dividing for this approach. For this one, we are dividing, right? So, if we have the operation in that given number that we have in base 10 to be converted to base 2, if the what? The operation is what? Division. So that means we are going to consider opposite operation to division. And what is the opposite operation to division? Multiplication. So instead of we dividing continuously by 2, we will be multiplying this one continuously by 2. So now,
So we get what?
I will explain. It's the remainder, but I'm going to show you how to what? To get your remainder. So it will be 0.6 times 2. So now, 2 times 6 is what? 12. We write down 2. Carry what? 1. Point. 2 times 0, you know we carry 1, right? 2 times 0 is what? 0, right? Plus 1 we carry 1. So this value that we have here, you will circle it. So circling that number, it means the number is no more 1, it is now 0. So this value is 1. For us to
So it's looking like magic.
no, that is how it works. This value that we have here is like the remainder that we are having here. So we have 1, right? But the value will be circled. For us to circle it means that it's no more the value that is in here. The new value is now what? Is 0. Do we get it?
What's the point of multiplying by 2?
Because what we have here, the point is because what we are having here, this is 0.6. This is 0.6 that is given to us in base 10. You know, we want to take it to base 2. So we know that this 0.6 is the same thing as what? 6 over 10. What is the operation involved here? Is it not division? But here, you will notice that this one is number without point. So for number without point, if we want to change it from base 10 to base 2, we'll be dividing continuously by 2. And we'll be recording down the what? The remainder, right? But if it is a number that involves division, meaning we have it in decimal form with points, in that case, we'll be multiplying. It will be the reverse of what we are doing here. That will be what? Done here. Do you not get the process now? So for me to circle this one, the intention is that the value that is inside here is not what I'm continuing with. The new value I will continue with now is now what? Is 0.
Because
So that is how the principle works. That is how it works. Yes. So now we multiply by 2 again. 2 times.
Where are we going?
Wait now. We'll stop somewhere because the idea is it might some process might have end. You know, if you are dividing, you remember fraction. We have 2 types of fraction. Oh, sorry. Decimal, not fraction.
Recurring decimal.
Now recurring and terminating. Terminating in the sense that the process will end. While recurring, it continue. Like for instance, if I should have 3 over 4, the answer of 3 over 4 is 0.75. It has an end. This process, if I should show the process, like the calculation, you will see that it ends. So we have 0.75.
Yes.
Now, what if I have, for instance, I have 1 over 3. 1 over 3 is 0.3333333. So this one does not terminate. So this one is recurring. This 1 over 3 gave birth to what? A recurring decimal. While 3 over 4 gave birth to what? A terminating what? Decimal. Do we get the logic now? So there are some cases where this process end, and there are some cases where it does not end. But here, it might not end. But if it does not end, you have to put a stop somewhere. depending on the question. Some question we ask you to approximate to 2 decimal places, to a certain significant figure, or to a certain, it depends. Decimal places, significant figure, or it could be whole number. It depends on the instruction. So yeah, let's multiply again. So 2 times 2. 2 times 2 is what? 4. Point, the new number here is what? 2 times 0 is 0, right? Is 0, right? So you circle it again. Yes, you multiply again. Don't worry. Let us continue. 2 times 4.
8.
This times this. 0, right? You circle again.
So
You multiply again. Yeah, the idea is, is in base 2. You can only have 0 and 1. The alternation will just be 0, 1, 0, 1.
Yes.
I get
You get 0.
It's just like division 2 that we're just taking the.
Exactly. Now, 2 times 8, 6,
0.1.
carry 1. 2 times, the new number is 6, 0, right? Is 0, then you what? You add 1 to it. You add 1 to it, right? So you circle it. But by the way, I'll be stopping here. Because from the look of things, it continues. Do you get it now? It continues. It has no what? End. Now, what will be the answer to this? 0.6 what in base 10. So this value will just be, is more like an approximated what? Value. Now, it will be what? Is 0 point, what you have inside the what? The circle. Is 0 point, is 0 point, is going to be this 0 point, then followed by the what? The value in the circle. So it's going to be what? Is 0.1001 in base what?
Is it from top to bottom?
In base.
ABC top to
No.
bottom.
From top to what? To bottom. Is the inverse of what is happening here?
Whatever is happening here.
Is the inverse that happened here. So now back to what we are doing here. From the equation back to this equation. The answer will be answer of this plus the answer of this, right? So the question given to us 110101 over 101 is equal to the answer of this 1010 plus what? 0.1001 in base 2, right? Each of them in base 2. So when you add, it will be 1010 point what? 1001 in base 2. It's the same, right? It's the same, right? But do you know one thing? You can confirm maybe you are doing rubbish or not by converting back to base 10. So if you convert this one to base 10, then you are expecting what? That you get this value 10.6, which represent this one. Should we try it together?
So if you want to convert this value to decimal point using the weight system.
Yes.
How do you apply that?
Okay. I get that. Now, using the weight system in this case now, though, I won't say it will be possible because, though I've not tried it, but it's a good question. I've not tried, but we can use the other index approach to handle that. Now, let us confirm whether this is correct or not. So we can end the class, or we can go for a break, any one of the two. So let us all do it here. So what? This is what we have, right? 1010.1001, right? In base 2, right? Now we want to use the other approach, that is the index approach. So the number before the word, the point, the normal way we assign the power, that is the way we assign it. So this one will take power 0, power 1, power 2, then power 3. Do you get that? But after the point, the power will be from minus. So it will be minus 1, minus 2, minus 3, then minus 4. So here now, let us what? Do it together. Are we together? Now let us what? Use that approach. 3 times, it will be 1 into bracket 2 to the power of 3, right? Let us what? Omit the whatever one that has zeros, right? Plus what? 1, 2 to the power of 1, right? 1, 2 to the power of -1. 1, 2 to the power of -4, right? So 2 to the power of 3 is what? 8. 8 times 1, 8, right? 2 to the power of 1 is what? 2 times 1, 2, right? Now, if I may ask, what is 2 to the power of -1? That is 1 over 2. That is 1 over 2 to the power of 1. Okay. Meaning, let me just what? Generalize it. Meaning, if you have this, a to the power of -x, it means the removal of that minor from the power means 1 over the remaining number. The remaining number will be a to the power of x. Do we get it? So the removal of that minor from the power is the cause of that 1 over. So, and what we are going to have down there will be what? Will be the remaining number, which is a to the power of x. So yeah, this 2 to the power of -1 is what? 1 over 2, right? So 1 over 2 times 1 is what? 1 over 2. Plus, what is 2 to the power of -4?
Our 1.
No, you have 8
It's 2, 1. Wanted to do 1 into brackets, 1 over 2.
And now 1 times 1 over 2.
No, you already added extra 1.
No, you know, we want to add everything together.
No, there's an extra 1 in bracket.
Oh, I get.
I wanted to use it to do into bracket before.
Okay, thank you.
Yeah.
So that is 1 over 2. 1 over 2, right?
Yes.
Plus, what is 2 to the power of -4? 1 over
16.
2 to the power of 4, right? That is 1 over 16. You can use this as a guide, this one.
1 over 16.
So 1 over 16, right? So 8 plus 2 is what? 10, right?
Yes, sir.
Is 10 plus, let's solve this LCM. Let's what? Simplify the LCM. LCM of 2 and 16 is what? 16, right? So how many 2 can we see in 16? 8. 8 times 1. 8 plus 16 is 16, 1 times this. So we have 10 plus 9 over 16, right?
Another one.
Now, this 9 over 16, when you solve it, can you use your calculator there?
3 over 4.
Instead of me cracking, wasting time more. 0.56. Now, when you add, that is 10.56. You know, approximately 10.6. You know, what we have is an approximated value. That is why we have this to be like this. But you are sure that, yes, your answer is correct. We are very sure that our answer is correct. Yes or no? So, this is where we stop. So, as a form of review of what we discussed in our last class, we're trying to look at how to change a decimal number with point to binary. So, for instance, let's say I have a question like this. I have 10.35, for instance, as a question. So this number, we have it in base 10. So, and the intention is what? We have to convert this to base 2, like convert this number in base 10 to binary. So meaning we want to convert it to base 2. So what we just need to do, as been explained yesterday, we will still follow the same procedure. So this one is just like a review of what we discussed to know whether it is properly taken or not. Now, solution, we have 10.35 in base 10. So this one is a number in base 10, a decimal number with point. So now, and I make it clear that a decimal number has what? 2 parts. So the part before the word, the point, and what we have after the point. What we have before the point is the integral part, right? And what we have after the point, talking about point, whatever thing that follows. In this case, 0.35. So that is the word, the fractional part. So what we have here is equal to, we can split this to this, 10 in base 10 plus 0.35 in base 10. Don't be confused. This 10 that we have here, it is what seen as a single word number, not 10 per se. 1 is on its own, 0 is on its own. Because we know that number in what? In base 10 should range from 0, 1, then down to what? To 9. So this number is just what? 1 and 0. But we know that what? We are having it in base 10. So what we need to do is, this one, we'll change it to base 2. This one will be changed to base 2. So I just want us to what? To observe something, that this value without point, this one without point, if you want to change it to base 2, we will be dividing it repeatedly by 2, since we already have it in base 10. But this one that involve point, meaning point a number, because 0.35 can also be seen as 0.35. This one, if you want to convert it to base 2, we will be multiplying it repeatedly by 2. And the number in the circle will give what was the answer. So now let's do it together. So for this 10 that I'm having here in base 10, it will be equal to this. So we want to divide by long division. So 10 is here. So we'll be dividing it repeatedly by what? By 2. Because the intention is to change from base 10, to change 10 in base 10 to base 2. If the question also asks me to change this 10 to base 3, that means in that case I will be dividing repeatedly by what? By 3. And I will be recording that remainder. It's still the same procedures. So now here I will be dividing repeatedly by 2. 2 in 10, 5, remainder 0. 2 in 5, 2, remainder 1. 2 in 2, 1, remainder 0. And 2 in this is what? 0, remainder 1. You must always ensure that the last value here end with what? Is 0. Anytime we see that this value is beyond this, so we'll just write 0, meaning this one is more than this. We'll write 0 here. Remainder, whatever thing that is there will be the remainder. So back to the solving. So our answer will be taken from bottom to what? To top. So that means we have 10 base 10 to be equal to 1, 0, 1, 0 in base 2. So now it's now for us to convert this to base 2. We have 0.35 in base 10. So for this, we won't be dividing repeatedly by 2. We'll rather multiply repeatedly by what? By 2. So it will be 0.35 times 2. 2 times 5, that is 0. I will write 0, carry 1, right?
Yes.
So this is the 1 here. 2 times 3 is what? Plus the 1, that is 7. 2 times 0 is 0. So the number that we have as our integral part, the one that we have as our integral part for this result, we are going to circle it, meaning the value is now what? 0. The new state of that value is now 0, irrespective that is 0 that is there initially. So now I'm going to circle this. So we'll move again, times 2. 2 times 0 is 0. 2 times 7 is 14. I'll write down 4, carry 1. This is the one I'm carrying. 2 times 0 is 0 plus the 1 carried. So that is that is 1. So that is 0.1. So we'll circle this one again, which is the integral part of the new result. So we go again and multiply. So this process, in some cases, it terminates, and in some cases, it does not terminate. But here, this one does not. But it depends. For some question, you will see that you end up having the result here to be 0.000. And in that case, when you keep multiplying by 2, it will be returning 0. So there is no point. That means that won't terminate. So here now, let's see solve one step. But for a question like this, there might be what? Additional information. Leaving your answer to a specific word, decimal places, or significant figure. It depends on the question. So here now, 2 times 0 is what? Is 0, right? 2 times 4 is what? 8. And 2 times is 0. You know, the new value here is 0, so that is 0. So we circle that also. So I can continue. But with the look of things, it seems this one won't terminate. From the look of things, you keep what solving for this. It does not terminate. So let me just stop here. That means 0.35 in base 10 is going to be equal to 0. It's going to be 0. What we have in the circle. So it's going to be this 0. What we have in the circled number, that is 0, 1, 0 in base 2. The question?
So what's the rule for us to say, okay, this has terminated?
This is what? Terminated.
Yes.
So terminated in the sense that here, all the value will be what? Is 0.00.
Okay.
So, you know, when you keep multiplying by 2, you will still be having 0. And the point is, if I should have a value like this, 101.11000, I can keep adding more zeros. Do you know that these zeros that is here, I can neglect it. I can just come and write 101.11. These zeros here, after point, like at the extreme part, talking about towards the end, can be neglected. So far it's not in between 1. It's not midway. We can neglect this. You can prove me wrong by what? Pressing your calculator. Just press this value. What your calculator will return as value is what? 101.11. Meaning these zeros, they are just there. But we can what? Ignore them. I can decide to what? To add more zero here. At the back of this. I can add more zero here. But those zero has no what? Importance. So I can just neglect them and simply write 101.11. But in a case like this, 101.101000. Now, the question is, which zero are we going to neglect here? Will this one be part of the word? The zeros will be neglecting. This one is not part. It's only what? This one that is not found midway between numbers. Why we are neglecting it is not because we are having a point here. You can't tell me that if I have 11010, that this zero will be what? Overlooked. That this zero will be overlooked. No. Because we didn't have a point in between. Please, am I making any sense? I've answered your question.
Yes.
Thank you.
So this one now, this zero was terminated.
This one, zero, this zero, right?
0.
Yes, we can just write 0.01. But one thing is why I might still decide to leave it. You know, I just stop somewhere. There's no instruction that leave your answer to 3 decimal places.
That means you can continue the other way.
Yes, you can continue. But one thing is, this process does not end, does not terminate. See, it doesn't what terminate.
You said something that this decimal, that some of them terminate.
Yes.
Which is that the ones that are not recurring decimal. You don't have like, it's not like pi, or it's not like the one that we got 1 divided by 3, that will have 0.3333333. That's the one that is recurring, right?
Yes.
and then we have another one that that can actually end, that has, like, if you calculate it, that's a specific.
Yes.
So
Meaning the process does not continue.
Yeah, it does not continue. So my actual question was that, whether I did the one for like the one that I think we did not 3/4 yesterday, I gave us 0.75. How do I say, okay, this is the last one? At what point did I get that?
Yes, like what we have here, what we are having here won't result to that. It won't terminate, in the sense that, let's assume that I have this end number here. After multiplying this value by 2, for instance.
No, I get this one. Yeah, I'm saying for the other parts. I get this one that doesn't terminate, I will stop.
Okay.
So I'm saying if I'm doing for the one or 3/4, the one that can be like, if I get 0.75, how do I know that? Okay, at this point, that everything will be 1, 1, 1, 1, or everything will be 0, 0.
Okay, let me use this one as example. Let's say we have 3/4, right?
Yeah.
So this 3/4, the answer is 0.75. How come? So we are using this approach, long division, right? 4 will be placed outside, then 3 inside. Now, how many 4 can we see in 3? It's not possible, right? So we are going to put 0 here with point. So because of this point, we are going to add 1 0 at the back of that 3. So we have 30, right? How many 4 can we see in 30? That is 7, because 7 times 4 is 28. So 7 times 4 is 28. So that 28 will be subtract from 30. We have 2, right? So we go again. How many 4 can we see in 2?
0.
Is what?
0.
It's not possible,
Yeah.
because this 4 is more than 2. So because of this point that we've added earlier, we'll add 1 0 at the back of that one, 2, to make it 20. So how many 4 can we see in 20? That is 5. 5 times 4, 20. So here, what we subtract? 0 minus 0 is 0. 2 minus 2 is what? Is 0, is nothing. So here we have remainder of 0. So anytime we have remainder of 0, the assumption is what? It terminates. Because there is nothing to solve again at this point. But looking at what we are having here, this process still continue, because we still keep what? Multiplying for this.
That means the example that you have doesn't work. But let's give this 10.35 now. Yes.
Sorry, I'm
so
coming.
the one that we are doing the multiply for,
Yes,
is for the decimal. Are you saying that we are not having decimal point that will actually terminate?
no, there are some that will terminate.
That will be using this press of times 2 times.
Yes, there are some that will terminate for this.
So my question is, how, like, you are not getting my question yet. How do you multiply now? 0.7.
Oh, I'm going to write the question down that will lead us to that.
So
Exactly.
something with 75 will terminate.
Yes, something with 75, 0.5, 0.25, yes.
So my own question is, at what point, look at this one now.
This one can never terminate.
Yes.
Can't terminate.
Exactly. At what point, what answer do we get on the bottom that this has terminated?
So you're saying that I'm trying to identify if it's going to be recurring or if it has actually terminated.
Yes, that's my question.
It's just, all of this is just your intuition. This one not terminate, this one terminate.
No, you must ask specific rules.
No, you for now just say this one terminate, this one terminate.
Okay, now back to what we are solving. So 10.35 in base 10 now
1
is equal to, we splitted it to this, right, plus this, right, and this one we have a value to this, right. So the value of this one in base 2 is what? We have it to be 1 0 1 0 in base 2, right, plus this other value, this one in base 2 is this value. So it's going to be 0.010 in base 2, right? So here now, when we add this plus this, so definitely this one, we only add to the integral part of this one. So the answer is going to be 1010 base 2 plus, point 0.010 in base 2. So this is what we are going to have to be our answer for this question. So I'm going to give you something to what? To work on, because I want to join the meeting. So you will be solving this. So a practice question. Practice questions. So you convert to binary the following. So the A part is 23.25 base 10. B 1, 2, 3. 1, 2, 3. Point 0. 75 base 10.
075.
Yes. No, there is no 0. 123.75 base 10.